Okay. Before we kick off, I wanted to address two questions that came up yesterday. And I can't quite remember who asked them, but there was one question about the cloud environment and whether someone who goes into your same workspace can start the cloud environment that you've created. Was that the person who asked that question? Are you here right now? Yesterday?
Yeah, I asked a question related to that, Roland.
Yes, Roland, thank you. I'm so sorry I couldn't remember who asked it yesterday. The reason I'm bringing it up again is because I actually misspoke, and I wanted to clarify. So when you're creating a cloud environment in a workspace, in a shared workspace, the cloud environment is still unique to you. So what that means is you can use one of the default cloud environments and you can tell your colleague which cloud environment you use, but they'll still need to select that cloud environment and start their own virtual computer. So they can't see the actual cloud environment that you personally created.
So which means that if we are three working on the same project and you kind of share your Jupyter notebook with others, they still have to power on a different machine. So 3 times the compute power for 3 analysts. Is it the case?
I think so. I think that's correct. Yes, you would need to create, if you want each person to be able to create their own, if each person needs to create their own cloud environment to use it, then yes, you would need, each person would have to spin up a computer, yeah, to run that notebook. Now they can share the notebook and see the analysis. So if you run the notebook and you're just trying to share with a collaborator just to show your results, that doesn't require spinning up a computer. But if anyone wants to run code on their own, then yes, they would need to spin up a computer. Now you don't have to have all 3 spun up at the same time. So really, it's not 3 times the computing power. And in fact, when you're working in a shared workspace with a notebook, if someone tries to go into the notebook while you are using it, they won't be allowed to save any code. They can only go into what we call playground mode and play around, but nothing will be saved. And if you're not working at the same time, you don't have to have your computer running while someone else is running their computer. So it doesn't have to be 3 times the compute if you're not doing it at the exact same time. Does that make sense?
Yeah, it makes sense. So I went wrong, I mean, based on the wrong assumption, but yeah, it makes sense. We are just trying to figure out again, as I said, how we are going to be working on, setting up our project on this. So thank you for your answer.
Yeah, thank you for the question. I'm sorry for the confusion yesterday.
Actually, Liz, just a follow-up question to that then. Yeah. So these 3 cloud environments get spun up. It's the costs are still associated with the single billing project owner or whatever that term is, right?
That is correct. That is correct.
Okay.
Yeah,
okay.
and Kayla,
Thanks.
you had a comment you wanted to add on to this? Oh, you're muted.
Thank you. I just sent you a message for a participant who she doesn't have breakout rooms as an option. So if you could just add her to your room real quick, that would be great.
Let's see, Jack. Yes.
Thanks, Liz.
Thank you. Let me see.
And Stephen, thank you for the question on the billing, because that was another question that I was actually struggling with. Thank you. It also clarifies the situation.
Thank you. Yeah, oh, no problem. And thank you all again for the questions. The second question that was asked was, I think Fred may have asked this, and again, I apologize if I get this wrong, but was about kernels, how many kernels you can spin up. And I wanted to confirm that you're referring to the Jupyter Notebook kernel, correct?
Yes, the Jupyter Notebook kernel. How many instances can I open? For example, if maybe I want to analyze quite a number of things in parallel.
Yeah. So you can actually open up so as long as you're using a Jupyter notebook image that has both R and Python on it, you can open up any number of notebooks, and it doesn't matter if they're on the R kernel or Python kernel at the same time. So you can do that. You can work in multiple notebooks at once. And yeah, and then the reason I was clarifying that question is because I think I may have misunderstood kernel for node. And I wanted to clarify that for those who need to use a Spark or a cluster to set up their analyses. So anyone who's using, for example, Hail, we do have options to set up multiple nodes as well. So just wanted to put that out there.
That's great.
Great. Okay. In that case, go ahead.
I'm sorry, I have a question regarding the data. It's if, for example, there's a data set on Terra, but somebody would just Google looking for that data, would it have a link that says it's on there?
Well, so remember that there is data hosted in something called the Teradata repository, but a lot of consortia data that can still link to Terra nothing is actually hosted on Terra. It's all in cloud repositories. Right. So Google, and right now Terra is built on the Google Cloud platform. So if something's, in a Teradata repo, I believe it's on the cloud background. Pamela, is that correct? Do you know? It is. Okay. And Azure's coming too soon. But so in general, no, it won't say that if you are to find something by Google searching, it would not say this is on Terra, because nothing's on Terra. It's all in its own storage. The consortia there are different consortia that do have an export to Terra option, which just makes it very convenient for you to get pointers, links to those data files where they are in their cloud locations into a data table automatically.
Yeah, I guess what I was saying is like it would lead me to be able to download it through Terra.
Not necessarily. If it's you wouldn't download it through Terra unless you import the data to a data table in your workspace.
Okay.
Yeah, and we'll get a little bit more practice with that today. So if you still have questions about it, definitely ask as we're doing it, because we're gonna practice what it's like to export from one of these repositories that does link to Terra. We're also going to practice what it's like to have sometimes there will be a scenario where you have a manifest, essentially just like a tab separated file that points to data in the cloud. And you can make a data table out of that and upload it. You can also upload it to your Workspace bucket so that you can work with it in the cloud. So we'll get practice with both those scenarios.
Yes, perfect. Thank you.
All right. Okay, so I'm gonna go ahead and share my screen, and we're gonna start by finding our workspaces from yesterday. So I have got mine pulled up here. Can everyone see this screen? Can everyone see?
Yes.
Yeah, thanks.
Yes.
Okay, great. Okay, so if you're coming back to Alwazi powered by Terra for the first time, you can go to alwazi.terra.bio, and you can access your workspaces either from this card here where it says View Workspaces, or you can go to your workspaces from the main menu. And what this looks like is several options. You can search workspaces by text up here. You can also search workspaces by billing project, access levels, tags, or submission status. All of the workspaces that you have created from scratch or cloned will be under your workspaces, but you'll notice you can also access other featured and public workspaces on these pages as well. Now, I remember I told everyone to make a unique name yesterday. This is where it can be handy because you can find the exact workspace you are working with. So I'm gonna look for my workspace right now, just by using my initials and the date, which I appended to the workspace name. And I'm gonna go into it. So go ahead and find your workspace 2 for the day that you made yesterday. All right. And then just as we did yesterday, we're going to need to start our cloud environment again. So if you are coming back, you should be able to just click this play button next to your cloud environment because you've already set up your virtual computer. If you're new to this today, if you weren't able to join us on the hands-on exercises yesterday, when you click on this cloud environment icon here, you can just click create next to the default option, and that'll spin up a cloud as well. So go ahead and start spinning your clouds up. And do let us know if you are running into any problems. We have a few minutes here because we have to wait for the cloud environments to start up. So if anyone's running into issues, it'd be a good time to maybe mention it right now. Okay. Was everyone, did anyone have any problems starting up their cloud environment? Okay. All right, great. All right, so as I mentioned, it's just going to take a few minutes here for it to kick off. We are going to start again at option number 1, data in a workspace data table. This is where we started yesterday. And just as a reminder, the purpose of this option 1 notebook is to show you how you can take data from a data table, which I'm going to open in a new tab now. How you can take data that's in a data table in your workspace and bring it into a Jupyter notebook. So we have this data table here, this sample table that has synthetic 1000 genomes data. It's all phenotypic. And we just want to bring it into our notebook so that we can start exploring it in real time. All right, so I'm going to go ahead. I clicked into notebook 1, and you can too if your cloud environment is running. We're going to select the open option. Now, we did turn off the kernel yesterday when we paused our cloud environment. So we're going to have to import packages again. So from the section 2.4, if you do load Python packages, you can click in to the code block on 2.4 and do shift return or press the run button. So go ahead and run those imports and then set up your environment variables as well and reload your data.
Sorry.
Just for practice.
Sorry, can I ask a quick question?
Oh, yes, sorry. It's a little muffled. Go ahead.
Okay, yeah, there's a step about the workspace. I had created actually a notebook. It seems I wasn't allowed to do that. I just needed to copy one notebook, right?
Oh, sorry. Are you just asking how to get into the notebook?
Yeah, because I see the notebook you are referring to, but it's actually not in my workspace ID.
So the notebook, it's not in, if you go to your notebooks tab here.
Yes.
There's no option 1.
No.
Oh, okay.
Let me just do that again. I'm sorry. Let me just do that again. But go ahead. I don't want to.
Oh, well, no, I mean, we want to make sure you can find it. So are you looking in your notebooks page right now?
Yes, I'm going back there. I'm going to my workspace again.
Now remember, yeah. So
yes, and notebooks. Okay, so I think it's just organized differently. The view is not.
Yeah, it does change. It does change depending on whether you've been working with the notebooks. So actually, this is a great point to point out. You can sort the notebooks. Right now, it's sorted by most recently updated, and so my option 1 is on the top. You can also sort them alphabetical as well.
Okay, no, it was okay. That's fine. And I think I'm now running the notebook 1. Thank you.
Great. Okay. So as I mentioned, go ahead and reload the Python packages And then set your environment variables. Your output, once again, should be your billing project, your workspace name, and the storage bucket associated with your workspace. And then go ahead and load the phenotypic data by clicking into these 2 code blocks and loading your table so that you can see. Another option that you can do that we didn't talk about yesterday is you can actually run all code blocks as well when you're doing this work. So to do that, you can go up to the cell option and hit run all. So if you know that a notebook's working, you're just maybe switching a file around, picking a new analysis file to work with, this could be a good option for you if you just want to run through all the code at once. And you also have that option when you restart your kernel as well. So we talked about clearing outputs. You can also restart and run all. I'm just having us go through this again today because we had the interrupt of the overnight, and I wanted to give everyone a little extra practice kind of working through one of these notebooks. All right, so I'm just going to go down again and reset the functions and do the plot again. So this is where we left off last time, is we did this little plot picking a variable. Now, I wanted to make sure everybody had enough time to play with this and do a different variable. So I picked HDL here, but I mentioned yesterday that you could go up to the table and pick a different variable. You can look and see what all the different variables are. You can also do this by looking at your sample data table as well. So if you want to pick a different phenotype criteria to look at, go ahead and do that and give it a try, just to see how it changes. And let me know if anyone runs into any issues trying this exercise here.
Hi, I have one question.
Yeah.
So when we read the table, we actually we feed in the arguments, what we got in terms of project, workspace, and bucket, right?
Mm-hmm.
No, and workspace. And the name of the table. In 3.2, I mean the second command.
Yeah, in 3.2, we are reading in, essentially, we're using that FIS API to get the entities that are in our sample data table.
Okay, so this is something fixed. Means every time when we're working in our workspace and we create a Jupyter, or we're in a Jupyter notebook, and the tables that are found in our workspace, we're just going to use this command.
Yeah, in general, this is, this is for like demo purposes, if you will. There are other example workspaces that I can point you to that use different FIS commands. But yes, in general, when you are trying to bring data in from a data table, FIS is a good option. And in this case, you can follow this template if you wanted to look at a different table. If you wanted to read in a different table into a pandas data frame. Yeah, this could be example code for you. But we are by no means saying that this is the only way to do this. This is a Python package. There are other packages that you can explore on Terra that people have already created notebooks and resources for, that you can kind of take code and play with it. One of those packages in R is the Anvil package. It's a bioconductor package, and it will also allow you to bring in information from your workspace, like your data table and your workspace name.
Okay, thank you.
Yeah, that's a great question. All right. And so we did the univariate distribution looking at just one, but of course, if we're actually trying to look at correlates in our data, we would want to do maybe a bivariate distribution. So go ahead and try section 4.3 here. So you can just get a sense of using one of these bivariate distribution plots in a Jupyter notebook. And again, you can take this code and practice switching up the variables. So if you don't want to look at BMI baseline and LDL, you can pick a different set of phenotypes to look at and run it. So go ahead and give that a try. That's a nice correlation there.
Liz, while they're doing that, can I ask you a quick question to clarify something? I'm a little bit confused. the platform.
Yeah.
So you mentioned that Terra does not actually store the data in the platform. Does that mean that the data is still in our cloud environment and Terra is just kind of like a wrapper around our cloud environment, pointing to everything?
Yeah. So this, sorry. So when you're working in the cloud environment, like a virtual computer, you are moving, accessing data and moving it into your cloud environment to explore it. What I meant when I said Terra doesn't store the data is when we say we import data to Terra, we're not actually importing the data. Terra itself, this platform, doesn't hold data. The data is stored in cloud storage somewhere. So what we do is we import links to the data. And unfortunately here, this is an example. So in the workspace data table here, we have imported reference files, right? But these reference files, they aren't located in Terra. They're actually located in a Google Cloud bucket. And in this case, they're located in the Broad References Google Cloud bucket. You can upload data to your workspace bucket, just like these notebooks are uploaded to your workspace bucket, but that is still on Google Cloud storage. Does that make sense?
Right, okay. Yeah. Okay.
However,
I think I understand.
But however, when it comes to working in these custom cloud environments, you do need to move data from one cloud environment to the other. So you need to bring the notebooks and files that you're working with into the cloud environment to analyze them.
Okay.
With some caveats there, but and the other thing I want to mention is that moving cloud data to cloud data is much cheaper than moving cloud data to local storage.
To local, right? Yes. Okay, got it. Thank you.
Yeah.
Quick one as well. Sorry. So so the data being on our cloud environment, when I see now on the left side here samples, the most interesting thing to me, because so I guess some of us can use Jupyter Notebook and pull some type whatever code in R or in Python there to analyze. The question is, I'm trying to see the point where you are actually linking your notebook to the data. The first part here, load the data, it just says sample. Is that?
So you're sorry, if you go back, I'm going back to my screen here. You're talking about when we bring the data in.
Yeah,
here.
Symbol equals simple, yeah?
Yeah, so.
That's what you do.
Yep, so we are using, so FIS is a package that can be used to grab workspace information. So it can grab the actual workspace table. This get entities TSV, I believe, can actually, you can label a table and pull it in. I haven't played with this too much, but I'm tempted. And then, so this is actually just pulling in the data from your table and telling how the data should be read into the Pandas data frame. So it's this right here that is actually pulling in the information from your sample table. I'm afraid to try this, but I'm going to anyways, because I don't want to mess this up. But I'm going to pull in Cohort really fast and just see what it does, just to make sure that this is running the way I think it is. If it's not, just forget what I'm saying, because I'm going to have to check with somebody. All right, there we go. Oh, it's having an error here. So, I'm not sure. That might be because
I think it's the cohort structure. I think you.
I think it's because of the ID here.
Yeah, okay.
I need to change this to cohort ID. Now let's see if that works. No, okay, still not happy.
That's a different structure. Okay, yeah. That's the thing.
And it might, you're right, it might just be the structure of the cohort table that it's not not linking here. So Pamela, if you have any suggestions too, because you may have played with this more than I have, but.
Yeah, I'm not sure. I haven't played with this notebook much.
Do you need to change the table name to cohort?
Oh, maybe.
A step above.
Yep.
Maybe run that yes first.
Yep.
And then next one.
See if we can get it. Nope, still not happy.
Because my concern is that, okay, I mean, this is my personal opinion because some other people have, I came here with an objective to, one objective is to know how to, if we go with Terra to, I mean, to know how to link our data from that may be lying. I mean, first of all, understand that our data has to be on Google, which I got it right now, and that how to pull the data from Google into the Terra platform as soon as, and do some analysis. And so far, I see how the analysis is done down. Yes, that, I mean, can be replaced with any piece of code that I want, but how did you get to get the data that is in your Google into this? This is where I am, you know, because we will have to do that somehow. And
yeah. So I'm unfortunately, like I said, I knew I was going to regret trying this as soon as I did it, because I don't want to mislead anyone.
okay.
I'm not a strong coder and I don't code in Python. So, so this is how it's happening. It is using the SPIS API to pull in the data table. This I know for sure is how it's happening.
Liz?
Oh, yeah.
Yeah, I changed that entity sample ID to tutorial-cohort because that's what it was called on the.
Oh, tutorial-cohort.
Yeah,
I
didn't get an error.
Okay. Still not. But, okay.
I would comment out that rename statement and see if that works.
Rename.
Well, I think
I mean, the idea is really not to, you know, I was just trying to see. I have my Google account. I linked it to a Terra billing account, and then I get into here. I create a workspace. Perfect. Now I need to interact between Terra and my data that's sitting on Google. So far, I still don't know it. This is
Oh, Roland, I'm sorry. So we are going to look at some other more basic examples of this. This is pulling in a data table using FIS. And in Python, FIS is one of the best ways to do this. I will find out how to make this so that it could pull one of our other data tables in. And I will send that to our group or to you, whoever's interested. But this is not the only way to read data into a notebook. This is how you can interact with your workspace environment and your data table. But more importantly, we're going to show you examples of how you can pull data that's sitting in other Google Cloud repositories. Because, for example, this data table is just phenotypic data. A lot of the files that you're going to be pulling in are stored in Google Cloud Storage. We're going to show you how you can directly pull those in as well. Like this is just one example. So I don't want us to get too hung up on the fact that FIS isn't behaving for me right now, but I will show you. So let's keep going because the next example we're going to look at will do some of this and we're going to get extra practice with it. And then we can come back to this question. Does that sound good? Because I think you'll see some examples that will be helpful to you as well.
Thanks.
Yeah. Okay, I'm gonna let's go ahead just for the sake because of these questions. I hope anyone who wanted to play here with these different graphs had a chance to kind of do that. And are there any other outstanding questions that I did? Okay. So what I want to do now is actually switch gears and go to the second notebook. Because what we're going to do for this notebook is exactly what we've kind of been asking about, which is how do you bring in data from other places as well? So I want everyone to go back to their notebooks page and select the option 2, data in a workspace bucket. And before you can open it up, but before we start working with this, I have a little exercise that I want you all to do. So this is getting back to this idea that not all data that you find in the cloud or across different repositories is necessarily going to have an easy export to Terra option where it'll make a data table for you. Sometimes when you go to a cloud repository, you're going to get essentially just a text file with a list of files or samples and their cloud location for those samples. And in that case, you need to somehow either bring that into your workspace or make that into a data table yourself. I'm going to show you how to just do that, bring it into your Workspace bucket so that you can play with it in the cloud. So now we're going to be focusing on data that's in a Workspace Google bucket. And this could apply to your collaborators Workspace Google bucket, your Google bucket, or other Google buckets too. Okay, so what I want us to do is navigate back in a new tab. I'm going to demo this first, and then I'm going to give you some written instructions and 5 minutes to do this yourself. So go ahead and just watch me for right now. Let's see. So actually, Pamela, would you mind pasting the link to the original ASHG workspace? Oh, not the ASHG workspace, the Quick Start workspace into the chat so everyone can easily access it? Thank you. All right. Okay, so here we are back on the original Quick Start workspace. This is a read-only workspace. If I go to the data page in here and go to the files, this workspace, unlike our clones of the workspace, holds some additional files. I want us to download this TSV file to our local computer. This is just for the sake of this exercise. I'm not suggesting that you would do this often, but we're going to download it to our local computer. And then we're going to rename it, give it a unique name. The reason it has to be unique is because we're going to be doing other things with this file in Jupyter Notebooks. So do make sure that you rename it to something unique. So it doesn't just say demo data.tsv. So I just put my initials on here. All right, so now I've saved it in my downloads as a unique name. And the next thing I'm going to do then is go back to my workspace, my clone, go to my files section, and I'm going to upload this file to my Workspace Google bucket, just using this upload icon. And I'm going to go to my downloads. And I'm going to choose to open this file into my Google bucket. One thing I want to point out while we're looking at this preview mode is what you'll see is that this is actually an exact replicate of the sample data table we have. So we can go into that a little bit more, but I just wanted you to know what you were uploading because it should look very familiar. Okay, so now this lives in my Google bucket, my Workspace Google bucket. If I wanted to, I could see this from the Google Cloud Platform side as well. There it is. Okay, so now I'm just going to give everyone 5 minutes to do that little exercise. And this will have relevance in a little bit, I promise.
I'm sorry, Liz, how do you clone that data again?
You don't need to clone it. So I have the instructions up here, but you don't need to clone it. All you need to do is go to this workspace link. Pamela pasted the link in the chat. So hopefully everyone sees that. And then just go to that workspace, go to the data tab on the original workspace, and you should see the TSV file there. And then you just click on the link and download it. Does that make sense?
Okay, download it for less than a penny.
Yeah, for less than a penny. Did someone raise their hand? Did someone have a question? And if you're already done, go ahead and raise your hand. Okay. And Fred, if you want to see a preview of the file, now that you've uploaded it to your Workspace bucket, if you click on the link, you can try and see if it gives you a preview there.
Yes, it does.
Oh, great. Okay. I only see about 8 people with their hands raised. So if you are doing this exercise, if you're running into any issues, do let us know. We'll give it just another minute here.
So as we wait up other guys, this means that, so if I have my workspace and we have already created data dumps on a local storage somewhere, this is how we simply upload the files for others to be able to access them in the workspace we have created so they can do analysis on the data.
That's correct. This is one way that you can do it. This is one way, yes. So if you have files on your local and you need to get them in the cloud so that you and your collaborators who are working on the same workspace can use them, you can do it this way. Now, anyone who makes a clone of your workspace will remember that the workspace storage is always connected with the workspace itself. So that means that anyone who makes a clone of your workspace will not see this file in their Google bucket. The only exception to this is the Jupyter notebooks that you make. Because Jupyter notebooks have basically an automatic copy built in behind the scenes. So when you clone or when you copy your workspace, the Jupyter notebooks will get carried over, but any files that are stored in your workspace Google bucket will not get copied over. If you wanted to still share those files, what you can do is make a data table and point to the files in your workspace bucket. And that way your colleagues can still see where they're located and use them from the data table as well.
Perfect. I hope that is the next step we are doing.
If we don't satisfy, we can definitely take time and show some extra stuff here. So let me know. All right. I'm going to go ahead and keep going then. So now you've seen how you can upload to a workspace bucket. So we're going to go back to this option 2 notebook and play around with this a little bit more. So this notebook is also, if you just want to watch me for just a second, this notebook is also in Python 3. And the goal of this notebook, once again, is very similar to what we just did. And the data, as I mentioned, is actually exactly identical. So, but I wanted to point out that this notebook has an extra package that we're going to pip install. So you can install extra packages when you're working off of these cloud environments. And so if you want, just go ahead and run this pip install session info. This package is a package that will allow you to document the code provenance in your notebook. This is very important for reproducibility, and we recommend you do this. You always have some kind of way of documenting all the code that you've been using, because sometimes the cloud environments get updated and things like that. This is just one more step that you can do to keep track of your what code you're using. I'll explain a little bit more about those updates in a moment, but go ahead and run this set up your notebook section here. All right. Now, anytime you do a pip install on your environment, you definitely want to wait till it completely finishes installing. But then after it's done, you want to do a restart of your kernel when you pip install. So I'm going to go up to that kernel option and restart. Okay. All right. Now I'm going to go down to section 2.2, load Python packages, and load those. And if you don't get any output from this, that's a good sign. That means that your session info package installed properly.
I can't get the pip install to work.
So there is a notice.
It's grayed out.
It's grayed. It's grayed out.
Yeah, the end part.
I'm
running.
Oh wait. So are you you're actually in the open mode of your notebook, right? You don't see like a. Okay.
Really.
That's good. See, this is
too many buttons to push.
Hopefully they'll make sense though by the end of this. And I just, so everyone, if everyone else wants to know what just happened, when you first click into a Jupyter notebook, as you know, you go into a read-only mode, and then you have the option to open it as well. And for those who are wondering too, I mentioned that you can't work in the same notebook at the same time off the same workspace. So if someone else was using this notebook, this open would have an in use icon. It would also tell me if I hovered over it who, or if I clicked on it, it would tell me who was using it. But I can still do playing around with code in playground mode, but it won't save anything. Okay. All right. So hopefully after you've opened it into open mode, the pip install should be pretty straightforward if it's working. So then after you install it, make sure it is fully installed and that your kernel is not flashing or anything before you restart the kernel, because otherwise you might get another warning about the loading packages later on. So you want to pip install, load your packages, and then the rest of this code is actually very similar to what you've already done in the previous notebook. It's actually doing the exact same thing. So with the exception, and so we can go through these one by one just to show you, but with the exception of this time, we're not going to read in a data table. So we're not going to use FIS necessarily to read in an entity in a data table, but we're going to actually be copying our files in, moving our files from our workspace bucket to our cloud environment. So on this section 2.3, go ahead and run the setup environment variables again. And now we're going to copy data into the workspace bucket. So this is going to copy, this is an example of copying a file directly from someone's Google bucket to your bucket. Remember, I had you rename that file that we just uploaded. We're not using that file that you renamed yet. We're going to first copy the original file from the Quick Start workspace, the original Quick Start workspace, into your workspace bucket. So go ahead and run the two commands that are below here. And now that we had questions about how you can actually bring files into your cloud environment, in addition to being able to interact with data tables, you can actually move cloud files from one cloud resource to another using, if it's Google Cloud, using something called gsutil. So this gsutil command is actually going to copy, gsutil cp will copy the file, that demo phenodata.tsv, that's in the original Quick Start workspace over to your bucket. So go ahead and run again those two code blocks under 2.4. And again, if you have questions as we're doing this, feel free to unmute yourself too. Okay. After you've moved it, if you were to go back to your files, your clone now, the clone of the workspace, your file section, you should see both now the demo data.tsv and the file that you uniquely named. So you can see that gsutil actually moved that demo data file in. All right, so that's how you can use gsutil to move files to your workspace bucket. The other thing you can do is move files from a workspace bucket into your cloud environment. Now, you don't have to do this step. We're showing you this in a two-step process so that you can see how files can move between different resources. But you can also just directly copy a file that's in a public access bucket into your cloud environment. So using the same kind of commands. So we're going to go ahead and copy data. This section 3.1, we're going to copy the data into our notebook virtual machine or our cloud environment that's in our workspace bucket. So the variables that we've set up here are designed to bring in that demo data.tsv into our actual cloud environment. So we're going to set that up, and then we're going to use gsutil to actually move it. All right. And then we're going to look and see what files are actually in our cloud environment. So we're going to run this ls command here. And you should see now that in your cloud environment, the demo data.tsv file is in your cloud environment along with your Jupyter notebooks. But what you won't see is that the file that you brought into your workspace bucket that you uniquely named, that is not in your cloud environment. That's because we haven't moved that file into our cloud environment. It's in our workspace Google bucket. I feel like I just hit you all with a lot of information, so please let me know if you have questions about what I just said.
Hi, so the file that we moved specifically, I mean, we downloaded and copied, that's not appearing in the environment. So if you want to bring it, move it to environment, what do we do?
Yep, that's exactly what I'm gonna show you next. That's exactly, so thank you for asking. Okay, so for the rest of this code that's in this notebook, this is exactly identical to the previous notebook you just ran. So I'm gonna actually skip over looking and exploring the phenotypic data because we've done that. And you are welcome to go back and try this. I'm gonna use, there's a code block at the very end under provenance. I'm gonna use this code block to show you how you can move that file. So you're going to use gsutil, that same command that I just told you about, cp, to move it. So a quick way that you can grab that command is actually to go back into your workspace data page, go to your files section, and click on the file link. And now you see at the bottom, there's this terminal download command. You can also use this command to move into your local directory in your cloud computer. You can copy it by just selecting the clipboard. Okay, so I'm going to copy that command and go back to my Jupyter notebook. And I'm going to type the exclamation point because we're working in a Python environment and we're going to use it. This is a command line utility. And then I'm going to paste that command. So if you want to move your unique file over, this is how you can do this. And then I'm going to run this. And so what this is doing is we're using gsutil copy to move the file, and then this period at the end is going to move it into our cloud environment local directory. Now if I do exclamation point ls, I will see it in my cloud environment as well. Any questions about that? Okay. All right. Oh, the other thing I just wanted to show you in this notebook is you can run this session info for provenance. and then click on it to view all the different packages that you've installed for this session. So. All right. Okay, so we're going to go ahead. We can close out of this Jupyter notebook. There's one more exercise in these Jupyter notebooks that I wanted to go through, and that is data that's in one of those repositories in the Teradata library.
Excuse me, how did you get to that page? How did you exit out and get to that?
Yeah, great question. So I'm gonna just open this up again really fast, just to show you. So you can exit out of a Jupyter notebook by clicking the X button here next to the kernel information.
Got it. Okay.
And just as a reminder, in case people didn't catch it yesterday, if you ever wanted to open up other parts of your workspace in a new tab, you can right click the workspace name at the top. That's a link to that dashboard of the workspace. So you can move from there if you need to. Okay. Okay, so option 3, data in a Teradata library. All right. So for this one, I want everyone to go ahead and navigate to the option 3 notebook and open it up in your environment. This one is, notice that this one is actually in R. So now we're switching over to some R code. And we have a couple of packages that we're going to install in this Jupyter environment. So I want us to go ahead and start that installation process. And then what we're gonna do, this notebook is essentially designed in 2 steps. The first step is to find a cohort that we want to export. And then we're gonna import that data into a Terra workspace data table. And then we're gonna copy that information into our Jupyter notebook so that we can explore it a little bit. The data that we're going to be using today is 1,000 genomes data that's hosted in BigQuery, which is Google's cloud data warehouse. BigQuery files are accessed through SQL, and we're not going to really play around with SQL today. This is just, again, an example of how you can import data to a workspace from a repository and then bring it into your notebook. But we have another Jupyter notebook that you can explore the different SQL with BigQuery specifically. You can feel free to go back to that after the workshop and play around with it if that's something that interests you. Okay, so we're going to start by just getting these packages installed. So in section 1.1, go ahead and run those 2 code blocks in section 1.1. And then in 1.2, we're going to install the Leonardo R package. And then in section 1.3, we're going to install the BigQuery R package, and we're going to load the BigQuery and ggplot, and then the reticulate, and we're going to import FIS as well. Okay, and then we're going to load the R packages. Okay, so once you get to this section 1.4, you've run all the code in there. I'll give everyone just a minute here to run those code blocks. You don't need to wait for them to finish, just run them in succession, and just make sure that you are running them in order. So I'll give everyone a minute to do that. And then I'm going to demo to you how to find a cohort in 1,000 genomes. Okay. All right. So if everyone wants to pause for a second and go ahead and look at my screen, I'm going to show you how to find data in the Teradata library and import a cohort. So before we do this, I'm going to point out that in the table on our data tab in our cloned notebook, we have this cohort table. And there's one, this is data that was already imported from 1000 genomes, and it's called tutorial cohort. We're going to be picking our own personal cohort from this data and importing it to the Terra workspace. So what we'll see when we import it is that we're going to add essentially a row to this cohort data table. And that's because when you export from the 1000 genomes browser, it will automatically create a data table called cohort for you. So what I'm trying to emphasize here is that different data repositories have different table names for the data that you import to Terra. You can always change a data table name though. We can get into that in a little bit. Okay, so to find data in the Teradata library, I'm going to go back to that main menu, go to the library section and go to data. And we're going to pick the 1000 genomes low coverage. And again, you don't have to do this yet. I have instructions for it that you can follow if you need to refer to it. We're going to select the browse data option. And then you can go in here and pick different features of a cohort that you want to export to Terra. I do recommend that you keep both self-selected female and male in here, but you can play with the other criteria as well to create a unique cohort. So for example, I'm going to select 2 here. And to select the criteria you want, just click on the bars that you want in here. This is how this data browser works. And let's see, maybe I'll do one here and here. All right. Okay. So what this does is it creates a query for us automatically. So it's going to search for those participants that match the criteria that we selected. And then what we can do is save the cohort. And this is what's going to be added to our Terra data table. So I'm just going to call this LK cohort and save it. And then what's going to happen is I'm going to be prompted to pick a Terra workspace to work with. So you can start with an existing or create a new workspace. We want to bring it into our cloned workspace. So I'm going to start with an existing workspace. And again, this is where having your initials appended to the name can be handy. So I'm going to pick my Terra Notebooks clone and select import. I get a notice that my data has been imported successfully. And now when I look at my cohort here, I see that I have 2 entities in this cohort table. There's the original one, tutorial cohort, and here's my personal cohort. All right. So I'm going to give you all a few minutes here to find your own cohort and bring it into your Terra workspace. So go ahead and give that a try. And again, it's helpful for me to know to make sure kind of that most people who wanted to do the exercise have done it. If you raise your hand after you're finished, if you have your hand raised right now and you didn't mean to have it raised, go ahead and put it down. Otherwise, if you're done already, go ahead and raise your hand.
Hi, I have a question. I renamed my cohort as tutorial cohort and my initial. So in the, on the screen, I'm seeing both as tutorial cohort. I mean, if I hover my pointer there, I can see the new one. Is there a way I can increase the width of the first column?
Oh, that's a good, you should be able to increase the width of the column. Let me just kind of put this on the side here. I apologize, everyone. Let me grab this and bring it in. Okay. So if I go in, oh, wrong one. Here, let me bring this. Okay. So if you go in here, let me see if it, is this the original? Oh, this is the original. Sorry, here. Let me open mine back up. I've got a lot of Zoom windows open here. Okay. Let me open this really fast in a new tab so I can get to the data table easily. And then go into my cohort table. And right here, if you hover, can you see that?
Okay, yeah.
You can expand that.
Okay.
Is that?
Oh, yeah. Okay. Okay. And the first, I mean, the header. Yeah. Okay. Thank you.
Oh, yeah. No,
thank you.
Okay. So let me just move this back in.
Yeah.
Okay. All right. So hopefully, let me see how we're doing here. Okay. Is there anyone who wanted to export a cohort who hasn't exported yet? Okay. All right, so let's go into this option 3 notebook. Now, hopefully, if you've installed all your packages, you might see some pink dialog in here just telling you about the load process, and that's okay. The next thing we're going to do, just like we've been doing with our other workspaces, is go down to section 2 here. It's going to be called Set Project Globals. We're going to set our workspace environment variables. And then, so go ahead and run those code blocks if you haven't already. And then we're going to get the cohort query. All right. So run the first code in that block to set up some workspace, again, some variables for workspace and project. And then we're going to use that FIS API again to bring in our cohort entity, to define a variable called cohort entity. This is going to take that cohort table. So run that. And then we're going to set up a variable called cohort query. Now, what I want to point out to everyone is if you did not, what this will do, this cohort query, this will take the entity number that's in your table to look at it. So if you only want to look at the tutorial entity that you brought in, if it's the first entity in this table, in this data table, okay. If it's the first entity in your table, you're going to want to change your cohort entity index to 1. If you had 2 entities in there and you wanted to look at the second row of the table, you would change it to 2. All right. So you can, if you only have 1 entity in your table and this is still set for 2, you're going to get an error when you run the code downstream because you won't have an entity 2 in there. So, all right. So you can go ahead and run cohort query. And if you want to take a look at what the notebook is bringing in from the data table as a whole, you can just take a look at the cohort entity and see. And it'll list both the entities in your data table here. So I can see in my output, I can see my my cohort as well as the tutorial cohort. All right. The next thing we're going to do is called BigQuery, the BigQuery package. So I'm going to run the 2 code blocks that are underneath called BigQuery. And this is going to return essentially a table of my participant IDs for the cohort that I grabbed. So I have 298 participants here. and it returns each of the one column for me of participant IDs. All right. Now, participant IDs are nice, but maybe I want to join this information with additional information from BigQuery. So the example that's in this notebook is joining this with the self-identified gender information that's in BigQuery. So here, we're actually in this underneath this add data by joining with another table. We're setting up a query, an SQL query, and now we're not only going to look for participant IDs, we're going to take the gender of all of the samples in BigQuery, not just our samples, and then we're going to join that with only the participant IDs that we have for our cohort. So I'm going to first grab the gender information, so you can run each of these code blocks underneath this section. So you'll see when I look at the dimensions, when you look at the dimensions of the gender table, you'll see more participants than what you grabbed. And then with the merge table code, we're going to merge the information together so that now we have a new table of our participants in our cohort with two columns, one for participant IDs, one for gender. All right, and then after we've done that, we can plot the data and see what it looks like. So we're going to plot the two genders essentially in a simple plot. So under section 6, you can plot the data. Okay. So hopefully everyone was able to get through this. I'll give another minute to see if people have questions related to bringing in this data.
Yeah, Liz, I have a question. That featured data set, like that 1,000 genomes, where does that actually come from? Like, is that from another Terra project? And they said, oh, you know what, I want to share my data set with everyone and make it a featured data set?
I don't, so I would hesitant to call it a Terra project. 1,000 Genomes is a consortia that has made their data public. And they've worked with the Terra team to make it so that their data that's hosted in BigQuery can integrate with the Terra platform. But yeah, they've chosen to make it open source.
So if we had data which we wanted to share with everyone, we would say, I want to share my data with kind of everyone and somehow get it featured like that?
Well, I guess it kind of depends on how much data you have. So again, this was a huge project. The 1,000 Genomes project is a huge project. They did they sequenced 1,000 genomes, and so I don't know how they ended up making a repository just for their data. So yes, okay. In theory, you can do that. And if you want me to find out more information about kind of what that process looks like when working with Terra, I can do that. So just remember to give some examples of some of the other consortia that are doing similar things, like the Human Cell Atlas project, a huge global initiative, also has a data browser that they create separately. They're not necessarily, they are integrated with Terra in the sense that they're using the Terra data repository to host data, but they've created their own data browser independent of the Terra team.
Okay, no, you don't have to look it up. I was just kind of curious as to, if we were interested in sharing data with other projects.
Yeah. So if you're talking about a smaller set of data that you want to share, a great way to do that is through a featured workspace. You can choose to create a Google bucket that's public, and you can host that data in a public Google bucket and share it through a workspace. And then people can just go to the workspace. And this is especially handy if you want to share the analysis that you use to also work with the data. So we see a lot of people who are doing publications now will make a Terra workspace with hosting the data and the analyses that were used for that publication, because you have to have open source data anyways for most of the stuff you do these days. So that's another strategy.
Okay, thanks.
Yeah. All right. Okay, so hopefully everyone has seen now a couple of ways that you can bring this data in. And I'll try to come back to the notebook to readdress kind of that FIS issue that we were seeing, and it was pointed out that originally the table wasn't actually a table, so it's possible that pandas couldn't make a data frame out of that. So we'll come back to that, but I want to make sure we get through some other material too that could be helpful. All right, so what we're going to do now is talk a little bit about, I'm going to exit out of the notebook here. And if you all want to stop playing for a second, because I'm going to shift gears and talk about the cloud environment a little bit more. So we've seen now what you can do by creating a virtual computer. You can launch applications like these Jupyter notebooks and Galaxy. And now I want to show you a little bit more about setting up this cloud environment and some other things that you can do with it and what's really going on kind of underneath the hood. So we're going to leave the cloud environment running because we're going to be playing a little bit more in the terminal of it. So don't click the pause button or anything, but just watch for a second. I'm just going to click into it and explain kind of what the setup looks like on these. So when you go to customize your cloud environment, there's a couple of features that we want to highlight. At the top, as Tiffany pointed out in the billing section, you can see live real-time estimates of how much your running your cloud compute can cost, how much the pause costs, and how much your persistent disk costs. So notice these are per hour and this is per month. Then when it comes to actually setting up the computer, there are 3 components that we need to set up. The software, so the actual application that we're going to be running, the software that's part of it and all of its dependencies. The cloud compute profile, where we actually set up the computer itself, the memory and the CPUs. And then the persistent disk storage, which again, you can think of a persistent disk. This is a detachable persistent disk. So you can think of this as like a flash drive for your virtual computer. You can store files that you've generated through your applications on this disk and then take it out, completely delete your computer and then recreate it and plug it back in. So, okay, so let's talk a little bit more about each of these components. So we've mentioned to you that the benefit of working in the cloud is that you can share software and compute environments with your colleagues, the exact same software and compute environments. And the way that we do this is through something called Dockers. So Dockers are essentially portable packages of software and all its dependencies. And that's what you're setting up when you're setting up this application configuration section. So Terra has several Dockers that are dedicated to setting up Jupyter environments. So environments that you can run a Jupyter notebook off of. And each of these are slightly customized with different software packages. So for instance, if you're someone who does a lot of work in bioconductor, there's a Docker for that. If you're interested in using Hail for genomic analyses, there's a Docker for that. And then Python, and of course the default that we use today, which was GATK and Python. Now, as long as these images have, these Dockers have the R and Python installed, you should be able to install additional packages. So for example, on this default image, we could install Bioconductor today if we wanted to. It just makes it easier to have it pre-installed for you. You'll also notice a few legacy images. So these are all Terra maintained environments and they do get updated. So one important thing that we recommend doing is checking the version number of the Docker that you're using. You can always access previous versions of these Dockers. So if the default gets updated to a new version of Python or R, you can still access the previous version of the Docker image. So again, this is all about reproducibility. So if you're working with your colleague on a specific set of software, you can still access that specific set of software.
So how do we see what's installed on this?
Perfect. So we have the default selected here. So we just click what's installed on this.
Oh, awesome.
Yeah, it's nice. It comes in handy. Now this works for the ones that are Terra maintained. Unfortunately, if you create a custom environment, you don't have this option. I think that might be coming, but we'll see. But
I'm curious, there's a couple GATK environments there. Which one has PathSeek on it?
PathSeek. Is PathSeek a Python or?
It's a broad program.
Is it a Python or R package?
It's Python. GATK is part of that.
If it's already built into GATK, then it might just be on the GATK. That's PathSpec.
PathSeek is what I'm looking for.
Yeah. I can find out about that. Like I said, it might just be part of the GATK suite. as a function. Like, so let me just see.
Yeah, it uses Spark.
Yeah.
So it's to take shotgun reads and determine what pathogens are there, viral, bacterial, fungal. I've used it a number of times myself.
Okay.
So
Yep.
not on the cloud. I've only done it locally on our compute infrastructure.
If it's part of GATK, like I said, it should be something that you can call if it's actually part of the GATK suite. But we'll regroup with the group and ask that question. Okay, the other thing I wanted to point out, so these are Jupyter environments specifically here at the top. You can also, we have several community maintained Jupyter environments. So these are made by people in the community who have worked with the Terra team. They're verified partners. And so these will definitely work on Terra. We have one for Pegasus, which is a single cell analysis suite, and one for OpenVino integration with TensorFlow. And then we also have RStudio here as well. So if you're someone who uses RStudio, you can launch that using this option here. And while I'm kind of talking about this, I want to point out again, if you're looking at my screen, we do also have a Galaxy application. It's a little bit different than some of these Terra Jupyter environments, and it's launched from here in the Notebooks tab. I think I mentioned to you all earlier that we have some big changes coming to this Notebooks tab. This is going to be changed to analysis, and we're going to be able to launch these applications from a sidebar here. So basically, all these applications are going to be kind of grouped together and hopefully more easily accessed together. So that's coming very soon next week. They're going to put a beta version out for that, and you'll be able to turn that feature on and test it out for yourself. But for right now, you can launch Jupyter Notebooks and RStudio from here. Galaxy, you have to launch from inside the Notebooks tab here. But the process of setting up these images is very similar. Okay, so that's the different applications that you can set up using Dockers. You also need to set up cloud compute, and so you can choose CPUs and memory. We also have this enable GPUs, graphical processing units. So if you're someone who's doing machine learning, this might be a good option for you to use on Terra. If you also have packages that are kind of standard that you want to set up, when you first create your environment, you can use a startup script to create your cloud environment as well. So that'll basically take whatever's in the default and then add whatever's in your startup script. Yeah, question.
Can we add our own Docker image?
You can. I'm going to get to that.
Okay, great. Thanks.
With some caveats, though, of course. In the compute, actually, you know what? I didn't get to that. Sorry, I skipped over that. So let me go back up. So the question is, can we add our own Docker image? If you scroll down to the bottom of this application configuration, you see this custom environment option here. This is where you can type the container name. So you can link to this. But there's a caveat. These have to be based off of the Jupyter Notebook base images. So this is a case, basically, if you are finding that you just want to have a certain version of a package installed when you launch, of a software when you launch, you can take the current base images, add your software to it, and then push that to a public cloud repository. All of these Dockers live in the cloud. So that's one of the nice features. Like I said, anybody can, as long as they're public, anyone can access your Docker and use the same software that you've been using. You can search for other Dockers that are available on the cloud as well. This is more useful, for example, when you're doing workflow analyses, you can actually find Dockers that have your software installed. All right, so I'm jumping back down now to this cloud compute section. So we talked about the setting up the memory. You can also select different compute types. So today we've been working off of just a standard virtual machine. It's a Google Cloud Engine, but you can also set up cluster analyses and Spark single node analyses. So again, if you're using Hail as software, that's something you'd want to change. You can also change the auto pause. So if you want a 15-minute timeout of working in your cloud environment, you can change this. And then you have persistent disk storage. So it starts at 50 GB. That's actually been enough for me for some minor analyses to work with, but you can adjust that if you need to. And if you want to ever delete your cloud environment, again, don't do this today or change this today because we're going to be playing in the terminal in just a minute. But you could choose to delete your environment, and you have two options. You can keep your persistent disk storage and delete your computer, or you can delete everything. So perhaps after the workshop today, you might want to consider deleting everything if you're not actively using the materials, or if you want to get practice restarting a machine too, you could do that. Okay, so that's setting up the cloud environments and the different kinds of applications that you can run off of this custom cloud environment here. The other thing I want to show you is that this is a virtual computer. And so if you are someone this is more for coding people, but if you're someone who works off of your local terminal to run R or Python scripts, you can, go ahead. You can do that from your virtual computer as well. So there's a terminal icon here, and you can click into that terminal. And now we can explore what's actually in our cloud computer. Oh, there it goes. Took a second. Okay, so here I am. I'm in my virtual computer. I'm going to type ls to list, or actually first I'm going to type pwd to just list what directory I'm in. By default, when I go into terminal, I'm going to be in this home Jupyter environment when I'm working in these Jupyter notebooks, when I've set up an environment for Jupyter notebooks. Anything that's saved into this home Jupyter environment will be saved to your persistent disk. By default, when you're working in a Jupyter notebook and you're, again, moving files into your cloud environment, the home directory you're in is already within this path. So you don't need to worry about your files not being saved to your persistent disk. But if you're working in terminal specifically, and you change directories, you might just want to be aware that this is, it has to be within this path to be saved to your persistent disk. The other thing we can do is list the files and directories we have in here. And so you can see there's several different files and folders that are available. If I want to see the files that I've been generating and moving today using the Jupyter Notebook, I can switch into the directory that contains the name of your workspace. So I'm going to do that using CD, and then I'm going to start typing the name of the folder here that I want to type, and then I'm going to use tab to complete it. And then if I ls in here, there's two modes that you can go into. Files are always saved into the edit mode. So I'm going to change into the edit mode here. And now I'm listing my files again, and you can see, just like we saw in the Jupyter Notebook when we were working from there, these are the files that are actually in my virtual computer along with my notebooks. So I'm going to give everybody just a few minutes to play in here. If you're new to command line and you still want to give it a try, I have some instructions here that kind of remind you what these different like ls and pwd and cd do. But just take a few minutes and explore around and play, because again, this just kind of shows you how this cloud computer works and where your files are stored when you're working in it. So we're just going to take a few minutes to do this. Let's see. Someone asked a question if you can pull containers off DocStore. I don't know. I always get Docker Hub and DocStore, but DocStore, I'll have to go in and look at DocStore really fast. Let me just check really fast on that, and I will tell you in just a moment. So I thought that, let's see. I've primarily used DocStore for workflows. And tools written, so tools written in WDL and CWL, WDL and CWL. So I didn't know that DocStore hosted Dockers, but Docker Hub, which many of the tools in DocStore call on, Docker Hub you can, excuse me. Docker Hub you can store containers in. Basically, I mean, any public repository that hosts, or let me see, there might be a caveat listed on there. I'm going to go ahead and close out of here now. There might be a caveat listed on the cloud environment thing here, startup script URI. Oh, sorry. Custom environments just says it must be based off of a Jupyter image. I believe you can pull it from Docker Hub. You can pull it from what was the Google Cloud Container Registry, the container registry. And I'm not sure about some other options, but we could definitely find out other options for you if that would be helpful. Okay.
So yeah, a quick question about the compute type. I can see there are three types: standard VM, Spark single node, and Spark cluster. Could you just give an overview of the three?
You know, unfortunately, I can't, but we're gonna ask this in the main room because I believe Anton might be able to help with that. I just can't, I haven't worked with the different clusters very often, only in the context of Hail, where you do a Spark cluster to run your analysis. But what I can show you in this is that if you do choose to use a cluster, you can define the workers that you're using and the CPUs here for the cluster. So, and we might be able to find some documentation too for you in our knowledge base to kind of go over this. So let me write this down as a question for the big group because I don't know as much about that.
Okay, cool.
Versus Spark single node. All right. And we will need to be able to add our software and other third-party software to an existing Terra notebook.
I was in the middle of answering this one, Liz.
Oh, great. Okay, go ahead. You can. Do you want to
send some links?
Oh, you just put yourself on mute, but you can put it in the chat, Pamela. Thank you.
I'll send some links in the chat.
Okay, so we're almost out of time. I can't believe how fast this ran. So there's one thing I definitely want to make sure I show you all, and that is sharing a workspace. So I'm just going to click on, if everyone wants to just look at my screen, I'm just going to show you a couple of handy features here. On the vertical 3-dot icon underneath your cloud environment, you can clone or share your workspace. So Tiffany mentioned different kinds of permissions. Here I've shared my workspace with Tiffany. You can add the email here. You can also, if people are part of a group, you can assign an entire group to your workspace. I gave Tiffany access to my workspace earlier and I made her an owner, which means that she can share the workspace, she can compute, but there's granularity here. If I wanted to change her permissions, I can make it so that she can compute, I can make it so she can share, or I could just give her reader access here. So this is a way you can share your workspaces with your colleagues. The other thing I wanted to show you is we've done a lot of cloning of workspaces today. You can also just take parts of a workspace. If you're looking at a public workspace in our showcase section and something interests you, you can just copy it over to the workspace that you're working in. So for example, here we have these Jupyter notebooks. If I click on the vertical 3-dot icon here, I can just copy this to another workspace and use it there. All right, and the last thing that I wanted to mention is if you wanted to create a workspace from scratch, this option, you can also do with data tables as well. So if you click on a data table, if you just select all the rows and click on the option, you can also export that whole data table to a workspace. And if you wanted to create a workspace from scratch, if you go into your workspaces list, you see this plus icon here. This is just like when you clone a workspace, you'll need to fill in important information about the workspace. But this is a way that you can create a completely empty workspace. So no tables will be preloaded for you. No notebooks will be in there. Nothing will be in your workflow section. All right, I think we're gonna have to move back into the main room to take some questions and do some surveys. So if you have questions, that's great. We can answer them together as a group in the main room as well. If everyone could, just make sure you pause your cloud environment right now so that we don't keep them running. All right. And let's go ahead and navigate back. Let's navigate back into the main room. If you're, Pamela just gave some resources in the chat. So go ahead and take the time to click on those and save those links. The rest of us, we'll go ahead and migrate back into the main room if that sounds good.
Image that you can build from, and then you can try to use LabKey. You can try to install that on this Docker container, and then you can try to bring that.
All right, thanks everyone for jumping back on. All right, in about 13 seconds, everyone's going to be rejoining the main room. Okay. All right, welcome back, everyone. All right, so we are going to have some time for Q&A. There's two things that we wanted to do first before kind of regrouping together. We wanted to give you an opportunity to fill out the post-workshop survey. This is kind of important for us because we will modify these future workshops, including the future workshops we're doing for DSI Africa, based on your feedback. The link to the survey is in the chat, and we're going to give everyone 5 minutes to just fill this out. So go ahead and do that now, and we'll regroup at 9:49 or 4:49. And after we come back, I'm going to share some additional resources as well. So please don't jump off quite yet. Okay. All right. Thank you all for taking the time to start filling out those surveys. So we are gonna do a little Q&A, but before we do that, I just wanted to share some resources that are in the slides here and explain them really fast. Okay. All right, so here, what we have in the slide deck here are some links to get you started. And I wanted to emphasize that we have these new LeanPub courses available. So these are designed to be intro to Terra courses that you can take online through a open course platform called LeanPub. We've covered some of the intro to Terra today, as well as the introduction to the cloud environment. But if you want to navigate to these courses and try them out on your own, each course takes a little bit over an hour, we'd say, to kind of complete, and they have exercises. And they're beneficial because they walk you through using Terra documentation as well as a resource. So it'll kind of point you to where in the Terra knowledge base you can find answers. We'll just say that these are brand new for us, so we value feedback on them, and we are working currently to incorporate feedback into them. So we're going to be updating these quite a bit as we incorporate new feedback. Let's see. Oh, and these courses are also free. If I didn't mention that, these are 100% free. So the other sources that I want to mention are Terra support. So we have some getting started documentation on our knowledge base. Let me just open this up so you can see here the Terra knowledge base. So this is our knowledge base. It's hosted at support.terra.bio. You can get started with different documentation to kind of walk you through the platform features. The other thing I just wanted to mention is that we have Terra YouTube videos as well. So you can have a link to our Terra YouTube channel where we have both full webinars like this that are available to look at and explore, but we also have smaller quick tip things on minor things that you can do in Terra. Okay, so I'm going to stop sharing now and we can have some Q&A time. We had 2 questions from our group that we still have to answer. I don't know if Anton, did you have additional questions too that were outstanding from your group?
I think we had more or less gotten through the questions that we were talking about when we finished, but I'm sure people had more questions.
Okay, so if it's okay, I'll just dive in with those 2 questions that I couldn't answer. One was on PathSeek. I think PathSeek is a GATK program. They wanted to know which Docker image would have PathSeek on it. And I just wanted to confirm and see if anyone else knew for sure how they could access PathSeek.
Yeah, we have a workspace with PathSeek featured in it with an analysis. So let me double check that workspace and see if we have a Docker image already created for running workflows in the workspace or in the notebook. Let me check that.
Great, thank you.
And
I'd be surprised if it wasn't on there. It's one of the I think one of the best programs. I mean, I haven't used all of them, but that's a really good program. So I'd be surprised if it wasn't on there.
I'll have to tell one of the engineers that you said that. That's very nice. Yeah. We have to hear that.
While we're looking for that, the second question we had was, do any of the TAs know the different use cases for the Spark cluster versus the Spark single node? I mentioned that Hail is often used as a Spark cluster. Does anyone have more feedback on that?
Yeah, I don't. Yeah.
Okay, so we can certainly look for the better breakdown.
Oh, sorry about that. Actually, it just came to mind. Okay, sorry about that. I was like thinking one of the reasons we enabled Spark nodes and Spark clusters is to use Hail, and Hail is a tool frequently used for doing sort of genome-wide association studies type of work. So the difference between why one would use a node and one would use a cluster I can't quite answer that, but I know in general, like one of the drivers for introducing it was to support Hail.
All right, thanks, Tiffany. And we can try to find some more information on the single node versus the cluster mode of analysis too, and when you might use one or the other.
I think PathSeek also uses Spark.
Does it use single node?
I don't know that. I just know that when when it's running, it starts a Spark engine and does a bunch of stuff, a lot of threading, and yeah.
Cool. Well, thanks for mentioning that, because I didn't know that. So, all right. Are there other questions from the group on anything you saw?
I have a question. Have there ever been any questions about using Terra and GDPR compliance? So, making sure that data storage and data management and things like that are compliant with the GDPR policies?
GDPR specifically.
GDPR is like the European Union kind of sensitive data compliance and regulations.
So yes, there have been questions around that, but
Okay.
I don't know the answers to where we are with working with GDPR right now.
Okay.
Yep. So I have a question. I have a couple of questions. So my first question is, anything revolving around data sharing, one of the key aspects partners or people playing around that get to factor in is the issue of security. So apart from the user roles, which is owner and just someone who can read, is there any other security aspect which have been implemented on the same, be it on the front, be it on the back end as well? Another question is about, there was a mention about the cloud vendors, and you did mention about Google Cloud, Amazon, and Microsoft Azure. And so could you comment something about Amazon? I never heard anything about it as well, if there's any. Yep, and then the last bit is about, suppose you have your data already on Google Cloud and you want to connect direct to your workspace. Are there links or an API or something you can use, a tool you can facilitate that in terms of streamlining your data so that once it comes into your Google Cloud, it's automatically updated on your workspace without necessarily downloading and uploading to your workspace? Thank you.
Okay, those are great questions. Tiffany, do you have anything you want to say about the security on the back end in addition to roles?
I hate to say this, I was multitasking, trying to answer the PathSeek question in the chat. So I didn't get to hear the full question. If you could just say it one more time.
Yeah, the question is just, do we have, in addition to the roles that we can assign on the Terra workspace itself, is there additional security implementations on the back end for protecting data?
Okay, yes. So we talked about authorization domains, and that is an additional security feature. The way we actually work with some projects is, for example, the NIH, we work with TCGA data and target data. I'm just going to use those as an example. And we have a way in which we check an allow list for the NIH for those data sets. And we basically have users, if they want to use that data, they have to in their profile section, type in their ERA Commons information, and that'll check if they're on the allow list for that data. And then if they are, then they're able to actually get that data in Terra and look at it within a workspace. So I mentioned during the workshop that authorization domains are ways in which you can protect who can access your data. That's an example, a very extreme example of how through a partnership and through this project that we have with the NIH, we are able to control access to that data in a secure way. So if you want to use the authorization domains yourself for your own data to keep it protected, that is a feature that you can use. And essentially all it requires is for you to create a group. And whenever you create a workspace that you want to keep really protected, you add that group in as to the authorization domain. So that's another way of making sure that everything is kept secure. In addition, Liz mentioned this, but if you want to take advantage of the 15-minute clinician timeout, that's a feature we don't use extremely often because it's kind of annoying to use, but you can email the support team. I think we have an article about it, and we can basically create a group and add you to the 15-minute timeout so that you can make sure that if people are working on private data, they're kind of kicked out if they haven't been active for 15 minutes. So those are, I guess, 2 examples I can think of. Does that help?
Yep, it does.
Okay.
The other question we had was whether the Google Cloud, I forgot the second question, I apologize, Christopher John, but the third question was, does Google Cloud automatically update, is there a way that you can update your workspace automatically if the Google Cloud, if a Google Cloud that you have folder that you have access to updates the data? Like, is there any way to automatically pull data in if you're working in a folder that adds new data?
So I'm trying to imagine how this works. So can you walk me through like an example? So if you are using a particular Google storage bucket and there's new files added, is there a way to somehow just point to the complete bucket?
Yeah, to automatically bring in the files to a Terra table, for example, so that you don't have to, so that you don't have to keep re-importing the data manually as it gets updated, essentially.
Yeah, I'm sure you could write a script to do that. I don't know of a script that we've written to do that, like that we can provide, but I'd imagine that you could write some sort of script that like looks in a bucket and compares what's in the bucket with what's in your data table, and adds a row or something to your data table for a file if it's new. I imagine you could do something like that, but it would have to be like a custom script that you write and run. What do you think, Liz?
I mean,
it makes sense to you.
Yeah, I think it would definitely have to be a custom script. So as I mentioned, we can, for those who are in our session, you can use different packages like the FIS API to programmatically interact with Terra workspaces. So in that way, you could use that to write a script that could maybe pull that.
There's also the Anvil package as well. Anvil packages in R, I think.
Yeah, it's a bioconductor package.
And what was the other question from Christopher John?
Can you repeat it?
So the last one was about the cloud vendors, the Amazon. So you did talk about Microsoft Azure and Google Cloud, but I did not hear anything about Amazon. So what is the stand? Anything?
Yeah, we don't have a relationship with Amazon. So we do not have our services available on Amazon. Maybe one day, but right now we have partnerships, a new partnership with Microsoft for Azure. So that's supporting our ability to build Terra on on Azure, essentially.
Okay, perfect. Thank you.
Yeah.
I have a quick question, please. It seems like the Terra works only with the TSV file, not with the Excel file. It's not possible to manage this another file. Another file like Excel file, TXT, or only TSV file.
Yeah. So to upload to a Teradata table, it does need to be a text or TSV file to actually upload the table. But in terms of using Excel files, you can definitely host an Excel file in your Workspace Google Bucket. But you just can't use that form of a spreadsheet to create. You can, as you know, you can make a table in Excel and then save as from Excel as a TSV or text file. So if Excel is how you prefer to kind of make a spreadsheet, that you can do, but you just can't use the .xl format, XLS format to upload a Teradata table. Does that make sense?
So Excel offer this possibility to convert the file to store the file in TSV file.
It does, and I can even, would it be helpful for me to, I can, if you want to stay on, I can demo that for you, if that would be helpful. We can see if.
Yeah, Liz, I was going to say, I actually already have it open because I'm looking at a spreadsheet right now, so I can quickly show.
Thank you.
If that's helpful. So I'll just share my screen really fast. So here in Excel, I have a file, and I can choose down here a TXT, tab delimited.
We can't see your options, so it must not be sharing the whole thing.
Oh, dang it. Okay. Yeah. All right. Well, so I guess what I would do here, you can't see the option, but I actually don't see a ts.tsv option, but I do see a tab delimited text file .txt, and that's what you would choose as in the drop down. I'm sorry that you can't see that when I'm sharing my screen. I'm not sure why.
Hang on. I had just pulled up one, but Microsoft Excel decided to update right in the middle of opening. Hang on, I can still.
Yeah, maybe I'll take a screenshot.
I'm about to have it open.
Okay.
So let me just let me open this file now. Okay.
So yes, you can upload CSV and image data to your Google Bucket, and you can point to those files in your data table, but to create a data table, it has to be in a TSV or a TXT tab delimited file. I don't know if somebody in our section asked if you could bring us to CSV in. I'm not sure if they tested that, but I'm pretty positive it needs to be TSV or TXT.
All right. If it's okay, I'll just show this really fast, but I don't know if you saw it, but this is already a TSV, but you see, I've opened it up into Excel. I could convert it back to Excel format. So if I go to the file option and the save as option here, I can choose a file format to save it as. Like I said, right now it's already in tab delimited text, and that's totally fine. That's how we can save it. You know, but if it was not already in this, it would be defaulted to the Excel spreadsheet probably. Yeah, Excel. So here's the default for the most updated version. But so if that's all, you could just save it using this drop down as different file formats. You'll get prompted with a message like this that says some features may be lost if you save as text, and that's fine for what we're doing. We're not working across multiple sheets or anything. We're just making a single data table in one sheet here. So. Okay. Someone asked about Image data. Let's see. I think so. Does anyone know the recent status on image data, especially with the machine learning workspace? There shouldn't be any problem. Okay.
What exactly about image data? I know that we've explored integrating different types of viewers for image data, but we have not like made any progress on releasing anything like that into Terra.
So it because, for example, the merge ray in Uganda, we are collecting image data, of course, with the other biodata, which can come in as CSV, which is fine. But for the analysis with machine learning algorithms, we would need such views, as of course, as well as making sure that we're able to have this data uploaded and being analyzed. So are there any plans for that?
So this has come up with folks that want to do machine learning on Terra before. And I know that we introduced GPUs so that people could better do machine learning using cloud environments. So I know that people are doing that, but in terms of a specific example of people doing an analysis with image data, I think we can ask around and try to get an answer for that question.
Probably I can answer that, this Indesh. Okay. You cannot import those as a table, but you can still import that data file as a normal file and use in your algorithm to analyze the data. It's just you cannot import that as a table because the data type is totally different.
Right. So you can bring the files to the Google bucket of your workspace. You can set up a cloud environment, take advantage of GPUs if that's what you need to like have the right type of machine to do your analysis. And then you'd have to, either, I guess you'd either bring those files to that cloud environment or stream them in some way, if that's possible. I'm not an expert on this type of analysis by any means, but that's just some of the, I just know that we've introduced some features like that for helping support folks to do machine learning on Terra. And I'm going to just check our blogs. We have a blog that's pretty active on terra.bio. And here is a link to it. I just looked up machine learning, and there's a bunch of different articles about machine learning on Terra that might be helpful.
While Tiffany pulls that up, I did want to just confirm. I tried to do the CSV upload. It doesn't work for tables, but Derek pointed out that when you're working with FIS and you're moving files from a cloud resource like your Workspace Bucket or from Terra, you can specify the file type that you're bringing in, but that's on the FIS side. When it comes to actually uploading your table to a Terra workspace, you cannot choose a CSV. It has to be a text or TSV. But that being said, you could upload a CSV or any other file to your Workspace bucket and still bring it over into your cloud environment. So you could still use FIS to call your bucket and bring a file in and distinguish and say, this is a CSV file that's stored in my bucket. But you can't use FIS to upload a data table in Terra if it's a CSV.
So it seemed too complex.
yeah, when you start working with this, you're talking about a little bit more programmatic stuff, and it does get a little more complicated. But in general, just for organizing data and tables, it's just text or TSV file. So that's all. And we do have documentation that kind of spells out how to do data tables today, and some YouTube videos too that explain data tables. We didn't get around to playing a ton, at least in our group today, with the data table feature, but we have stuff that can walk you through that. The Lean Pub courses also walk you through making data tables from scratch and everything. So. Okay. All right. Are there any additional questions that people have?
I have a question. It's a whole bunch of questions actually, but it's quite a broad topic. But I'm curious about what has worked. So about sort of best practices and lessons learned by teams who have done work already, are very productive in Terra already, and sort of more general scientific computing in the cloud and sort of those things. I've looked a bit, but I haven't found much. That blog looks like a good start, but I'm just curious and interested about what people have learned or found works for them.
Oh, that's a great question. Yeah, so we can definitely look up and see if there's additional best practices information on using Terra. I think this is an ever evolving thing, because people are still doing, like, we're actively doing it now. People are using Terra for the first time in their publications, and so I think we're still figuring some of this out. What is
Liz, I can
okay.
I can talk through just some sort of guidance on how people typically get started with their projects, if that's helpful. I'll just say, I'll say some things. I hope it's helpful. For best practices, I think usually a good place to start is figuring out where your data lives and what data you need access to, and if you need any, authorized data, ensuring that you're able to get the data that you need into the Google Cloud Platform so that you can use it in Terra. So there's sort of some research there to do in determining, like, what's the data that you need for your question at hand, and how do you find it? Is it already available in the Google Cloud Platform? Maybe it is. And then when you're setting up, getting started with your team and with Workspaces, we kind of talked about how we have those Terra billing projects. Ideally you have, a Terra billing project that is somehow linked to a funding source where you can map back the analysis that you do in Terra back to a Terra billing project, or to a cloud billing account. So having that project set up with groups that are able to use that project in Terra is another next step. And then when you're actually getting going with creating your workspaces under the Terra billing project, people typically are trying to figure out how to set up their data tables, or what are the links to their input files, kind of creating their data tables to get started. If you have to do any processing of data, or any sort of something that you have to do over and over again on input files, people will use workflows. People spend time looking for other workflows so they don't have to write them on their own from scratch. So that's another step in the process. So people will spend time trying to find the workflows after they've already set up their data. if you don't need to do the workflows, you can skip right to the cloud environments, and, you know, either migrating scripts maybe you already have for visualizing data into a Jupyter notebook or into RStudio, or whatever your preference, Galaxy. And then from there, once you've done, you know, your analysis, making sure that when you're all finished, kind of determining how you want to deal with your data afterwards. Do you need to move the data off of the cloud? Do you need to, do you want to save your workspace and feature it to share with other users, like how you did your work? Maybe reference it in your paper. That's kind of another thing that people will sometimes do, is they'll create a workspace that demos their analysis with their workflows that they used, with a little bit of a sample set, small sample set, and then they'll show people how to do it and feature it. But yeah, those are sort of like kind of a high level overview of like the process that I've seen people go through. Hopefully that's helpful.
Thank you. That was very helpful.
Okay.
Sounds like we need to make a blog request for best practices on getting on Terra.
Yeah, definitely. Good idea.
That did remind me, I know Tiffany sent a link in the chat, but I also just wanted everyone to know that we do have a, did you mention this, Tiffany, about the blog in general?
Yeah, I did mention we have a blog,
okay.
But that's it.
Okay, well, we have a, yeah, I'll just link to the just general blog page here, which I'm sure everyone could find, but this is actually, I found this quite useful. This is part of our communications team, tries to take get user stories, user journeys, and put them into blog format so that you can kind of see how others have gotten up and running with Terra. So we've had citizen scientists come on and use Terra and tell us about both what they liked and their pain points. We've had we have a best practices for COVID-19 data in Terra on there. So if there's a best practice and other people have done it, you know, it might be on the blog too. Or it might be a place where you can find inspiration for using it, for using different Terra sources.
Question related to Terra, because Terra is a platform, and I see for the Alwazi, it was sort of customized for that project. So if someone else want to adopt the Terra as a platform, what's the recommended approach? Reinstalling everything, or there is a better way of easily customizing for that project?
For project, do you mean like Alwazi is a project and there's like a branded version of Terra for Alwazi?
Correct.
Okay, is the question like, how do you get if you wanted to do a branded instance with another project, how would you do that?
Yes. Okay.
We have a project management team. So what I would say is you can email, you know, the idea of what you're thinking of, or, you know, what's an example of another project that might want to do this, to my email, and I can forward you to the right people.
Okay. Yeah, because for the DS1, Derek and I are the data management, part of the data management core. And earlier we were thinking the Galaxy, but the Terra provides other capabilities and the pipelines that is sort of parallel to the Galaxy, but Terra, Galaxy can run inside the Terra or integrate with it. And it provides much better capability in the other expanded pipeline. And that's why I asked that question. So I'll send the email and start the conversation.
Great.
Tiffany, just to confirm, everybody has access to all branded spaces, correct? There isn't any private space.
Mm-hmm. Yeah, so these branded spaces, there's a few of them for projects, and if you create a workspace in Alwazi, you'll be able to see that same workspace in app.terra.bio or in our other branded instances. So I'll send you one example of a different one here. I think the only one that doesn't really apply to is All of Us, which is a different sort of product altogether, but.
Yeah. So basically you can kind of choose your favorite branding too and work within it as well. So.
But are all those still running on the same Terra platform with the branding customization?
Yes, it's the same platform. So like Tiffany was just saying, you can, anything that you make in a workspace on one, you'll be able to access from the other. So it's just kind of, preference and everything on which one you're using. Personally, I love the Alwazi one, and I think I'm going to just stick with it from now on.
Another question?
Yeah.
This might be in the many examples, but are there ways of consuming an API outside? So perhaps we have some very restricted data set and we only want to answer certain questions from within a notebook.
So just to repeat what you said, so you don't want to bring your restricted data set to the cloud? Is that right?
Yes.
Okay.
There are cases where, we can't export the data and we might only want to answer certain questions like yes or no, have you seen this snip? So one way would be to, it would be great is if I within a notebook on Terra could call that API and ask those questions.
Yeah. Yeah, so I'm just trying to think of how this would work. So you would want to be working from maybe a local machine, but you want to call a Terra workspace and bring information from that workspace locally to do some data analysis, then maybe push information back programmatically to a workspace or something like that?
No, well, no, exactly the opposite actually. So have a notebook within Terra where I am looking at a patient's data, their whole genome, and that's in Terra. And then I find some interesting snips and I want to query a very protected database outside of Terra.
Yeah. I don't know how that would work, but I can find out. And Liz, do you have any thoughts on that?
Do you currently query the kind of in the example you're thinking of? Do you currently query that database using command line from your local computer?
Yes. Well, I mean, this isn't built yet. We've done other things like that, but yes, it would be sort of a REST query with perhaps authentication.
Yeah. So I'm not sure what kind of software, because I'm not familiar working with APIs, but if it's software that you can install on your Docker image to use it, you should be able to query it then from within your virtual computer.
Okay.
If that's set up and you have your snips already in you've generated a list, say, of snips in your virtual computer. If you've installed that software, you should be able to query using that list.
Okay.
I have a question.
Yeah.
So I'm going to just go straight. Is Terra HIPAA compliant?
Oh, let me give you our technical language about whether we are HIPAA compliant. Give me 1 second.
Okay, that's nice.
Had this question before.
Yeah, I know. Let's see here. Okay.
Terms of service. Do you have it? Or?
Go ahead, go ahead. I was looking for something else. Yeah, but you can go ahead.
Is this the right, well, maybe it's not the right one. Yeah, here, this has the statement on HIPAA in it. You have to scroll down, but this is the terms of service for Terra. Oh dear, where did it go? Here we go. It'll say that Terra is not a covered entity as that term is defined in HIPAA. But on occasion, Terra may agree in writing with a user to perform services for the user in the storing of PHI, protected health information. And we recommend that users enter into a formal agreement with Terra/Firecloud.
Okay, because the question about that is related to the fact that Terra is interfacing with Google. I mean, Google Cloud, right? Pulling data and pushing data to the cloud. So in the meantime, we can have some EPA compliance requirement that makes us to have a certain level service level agreement or certain service level agreement, I would say, with Google. So now we want to analyze our data using Terra, and it means that according to what I've seen and to your operations, we're able to pull that data into Terra, run some analysis and share the data or push back the data somehow out of Terra into Google, again, into Google Cloud. So within that interaction, if so there is going to be a gray area when the data is not totally, I mean, when the transactions is not totally covered by the EPA compliance requirement, right? We have to be able to report on that. That's what I'm asking.
Yeah, so I think there is language in the second paragraph in that document I sent you around how to ensure that you're compliant, because Terra does offer compliant features, and so they have some recommendations that you enter into a formal agreement with Terra and Firecloud for doing that. But yeah, so
Okay.
I don't have more information other than what's in that service agreement, I think.
Liz, I have a little bit more information, I think. So these are some questions and some talking points that we have for like PHI and Terra. So the one question, is it okay to store identified information in Terra? Yes. Terra is a secure system. We are okay with taking on the risk of hosting this kind of data, assuming the data custodian is allowed to put identified data into Terra without additional compliance requirements, such as a BAA. However, connecting to this data is a risk, so we should carefully consider whether it would make sense for a given project. Okay, and we can't guarantee that some organizations may want to make us, I guess, get us to sign a BAA before taking it on. So I think that we don't currently sign these BAAs. And we're hoping to support them in the future. So that's something to know about. Okay, I'm just looking. Most organizations will have requirements about what we will do in the case of a data breach. We have a documented SOP and manual process for how we react in case of a breach. So that's something to know about. And we do have an SLA, but we're not like signing up to be compliant to the SLA with any sort of, I guess, issues in case we don't meet the SLA. So I think, yeah.
That's good to know. It was just really good to know because at least the organization, when they are using the system, they will know that maybe they can have a policy about the data that they want to put into Terra for analysis based on this specific requirement. So it's a good, no, thank you.
Yeah, and last thing I'll say is workspaces are already fully CLIA compliant, and CLIA compliance in the US. CLIA compliance. What that means is clinical laboratory improvement amendments. It's like a particular thing that allows us to have CLIA certified data, clinical data in Terra and workspaces, and that is something that people, our group actually does that. So yeah, hopefully that helps.
That helps, thank you.
All right. Well, if there are no other questions, we can say goodbye and thank you all so much for coming out today, for all your wonderful questions. This was fantastic to get to interact with you all.
Yeah, and I guess
Yeah,
we'll look
thank
forward
you.
to a future workshop.
Yeah, it would be nice. It was a good workshop. I felt like it needed a little bit more time to explore, other capabilities,
Oh,
like the
yes.
workflows
Yeah.
and stuff. But it's a nice introduction. Thank you.
No problem.
And you can be contacted for questions on billing and stuff like that, right?
Absolutely. You can contact us, or we'll also put the support email, support@terra.bio. That's another great place. You can email them as well.
Okay, that's perfect. Thank you very much for your support and for all the time taken for this workshop. Thank you.
No problem.
Thank you.
Thank you so much. Thank you very much for this great introduction to Terra. It's very helpful, but I think it just remember to show how manage the general file of data like Excel. So many thanks, and great for this opportunity. Thank you so much. Bye-bye.
Thank you.
Okay, so let's get started with our hands-on exercises for today. We're actually going to start all the way from the beginning of the first notebook. We can hopefully move through it pretty quickly, but that way we'll get to see the difference between the three notebooks, since their purpose is really to demonstrate how you can work with data that is organized in different ways on Terra. So the first thing we're going to do is we're going to start back up our cloud environment that we had going yesterday. So if everyone can go back to their workspace that they cloned yesterday, and you can start your cloud environment from any place within that workspace. I can be in any of the tabs. I can be looking at a preview of a notebook, and I will see this cloud environment widget at the top right either way. So
Anton, quick question.
Yes.
Can you show people how to find it if they just log on to Terra, their workspace?
Sure. So the easiest way to find your workspace is to go to the Workspaces section in the main menu right underneath your name, and either scroll through your list of workspaces if it's not too long, or you can search for any part of the name. You can also filter based on access levels. So a lot of times I'll just list all the workspaces that I'm an owner of, and then I'll sort them by last modified so that I can just find when I created them. So I'm just going to give everyone a moment to find their workspace again and press that play button. And then I want to pause and go back to the concept of cloning workspaces for a second, because I know it's going to take everyone a minute or so before their cloud environment is ready. And I thought we could recapitulate on the concept of the workspace clone versus the cloud environment virtual machine, because I know a lot of people were very curious about the different ways that you can share and collaborate on Terra. While we're waiting for environments to start, could you comment again on how Playground is intended to be used? Absolutely. So let me come back to that in just 1 minute. I want to start by reminding everyone that they are looking at their own personal clone of a public workspace. So I'm going to look at the public workspace really quickly just to emphasize what the difference is. So notebooks. Oh wait, I'll just use this filter, like I said. So notebooks, quick start. So here's the public version and here's my cloned version. They may look almost identical, but the big difference is, of course, that the Google bucket is going to be completely fresh and empty. You can check that either by going to the GCP user interface through this link, but you can also look under your data tab under files. So here's the public workspace, and here's my cloned workspace. It just so if you all look at yours, you will have only a notebooks folder here. I happen to have uploaded this a couple of minutes ago. Actually, I'll go ahead and delete it. So my clone is completely empty. What I did carry over with me is the metadata. So I copied everything that's in this tables section. And I added this manually also earlier this morning. So that gives you an idea of what carries over when you share a workspace. You can also send data. You can send metadata by copying it to another workspace, so export to workspace, and you can do the same thing with notebooks. Oops. You can do the same thing with notebooks. You can do the same thing with workflows, and you can do that from a public workspace. What I can't do from a public workspace is create a virtual machine. So you can see as I'm looking at the public workspace, this whole button is grayed out. I can't do anything in the cloud environment widget because I don't have access to this workspace to basically spend computational resources. In order to do that, I have to clone my own workspace, and there I can create a cloud environment. So this is a separate virtual machine with its own separate storage. And that's kind of what we're going to be emphasizing today, is that there's storage that's associated with the workspace, which we call the Workspace Bucket. And there's also a separate persistent disk, the persistent disk that's associated with the cloud environment. And you create this persistent disk when you create your cloud environment. When you delete the cloud environment, you have the option to either delete the persistent disk or keep the persistent disk so that it can be remounted to another cloud environment. And a lot of today's demonstrations are about basically moving things between the cloud environment and places like the Workspace Bucket. So that kind of brings us to the question of playground and edit mode. So hopefully by now everybody is more or less ready to start running. So I'm going to click on the first notebook that we'll be working on, option 1, data in a workspace data table. And before I open it, I'll answer the question about playground mode versus edit mode. So in either of these cases, we need to have a running cloud environment because both of these enable you to run computation. The difference between the edit mode and the playground mode is that edit mode basically auto saves everything you do regularly. Whereas playground mode, whatever happens in playground mode stays in playground mode. If you want to save something that you've done in playground mode, you have to make sure to do it manually, either copy pasting cells to another location, or you can use the file menu to download the IPyNB file. But playground mode doesn't keep your work saved to the persistent disk, and it doesn't auto save back to your workspace bucket. So the purpose of the playground mode is so that people can work in the same notebook at the same time in the same workspace. It's important to understand that people will not be using the same cloud environment, because every cloud environment is unique to the individual who has spun it up. So if I were to share this workspace with someone else, so I've now opened this in edit mode. That means that it's locked for edit mode until I leave the edit mode for this notebook. If I were to share this exact workspace with someone else and they came into my notebook, they would be able to open it in playground mode, and they'd be able to run computations, assuming I gave them writer access to the workspace so that they were allowed to run computations. They would be able to run an active version of the notebook, but it wouldn't be getting auto-saved to the memory, because that would run a risk of overwriting. So does that answer the question about playground mode? Hopefully. Feel free to pipe up again if you have more questions.
It's like, yes,
I'm sorry?
it answers the question in the chat.
Oh, great.
Just, yeah.
Wonderful. Excellent. So we're just going to go through each of these notebooks now. And we're going to pause occasionally for a little bit of exercise that will be self-directed. So go ahead and do all the things along with me until I tell you to do something on your own. So we're going to, I guess we can skip over a lot of the introductory information. I think.
1 second, really quick,
Yes.
Anton.
Yes.
Yannick, is the playground mode not really clear for you? We can go over that again. We can also have, okay, we can also have, so that, I don't think that, maybe we should try to explain that one again, Anton, the playground mode. I can also try to share my screen and show from your workspace's perspective, Anton, like what it looks like if I try to open the notebook, if that's, do you think that'll be helpful? I don't know.
Sure. So if I were to share the notebook with you, or if I were to share the workspace with you. Oops.
Yeah. Okay, so that's what we'll demo is Anton is going to share his workspace with me. It's Tiffany M at Broad. And then I will show you what it looks like when I try to access the same notebook.
Yeah, so this will be a great demonstration. And just to slow down so that everyone can see again, this is how we add people to a workspace. So if you have can share capabilities, then you are able to add additional people so long as they are registered on Terra. So that's what I just did.
Okay, and what I'll do is I'll share my screen so you can see what happens. So let's see, share screen, share this. Okay, so I got this email that Anton has shared owner access to this workspace with me. So I'm going to click on the workspace. And here's the workspace. I'm going to go to the notebooks tab. Anton, which notebook do you have?
Option 1.
Option 1. Okay, so now I'm going to click it. And it says open in use. And if I click on that, It says the notebook is currently being edited by Anton, Anton's email. You can make a copy or run it in playground mode to explore and execute its contents without saving any changes. So I can make a new version of it, make a copy of it, and then if I make a copy of it, I can use that on my own virtual machine, my own cloud environment, so to speak, or I can run in playground mode. And I still have to create a cloud environment to do that. So I can click create. And while that's loading, I can see the experience looks a little different right now. It's in preview read-only mode as it's creating. And then I'll be able to play with it. So if Anton and I wanted to work on this together at the same time, you know, say we're in a meeting together and we're trying to work on a project together, Anton could be the owner that's actually changing that version of the notebook. And I could be, you know, trying to do some other testing or whatever on my side. And then we can save back the changes to Anton's copy. Or I could have my own copy of it and we can save the changes to my version. Does that help, Yannick? Or anybody have questions about that? Okay, so I'll stop sharing and we can keep going. Oh, chat.
Yes, very clear with this example. Excellent.
Oh, good. Great. Okay, I'll stop sharing.
Awesome. Thank you, Tiffany.
No problem.
So yes, that whole time I was still in the edit mode, which is why when Tiffany tried to open it, it registered as being in use. So now we can continue with our notebook. And I'm just going to skip past a lot of the introductory information. Obviously, we need to make sure to import all necessary packages. There's some information here about the types of synthetic data that is a part of this workspace. So that's referring to this table, this sample table right here. And by the way, something that is very convenient for me is the fact that every one of these spots up here is clickable, and you can open it in a new tab. So I routinely just open my workspace in a new tab so that I can navigate to the data tab of the same workspace. So we're also going to set our environment variables. Again, setting environment variables is just a system that we implement to help the notebook look at its own workspace. So now the variables project and workspace and bucket all refer to the project and workspace and bucket of this workspace. And then we're going to load this table. And you'll notice that what we're doing is loading this sample table into our notebook. Oh, there we go. So let's see, the first 6 ages, the first 3 ages will be 75, 63, 48, right? So hopefully everyone is following along so far. So here are some of the options that you'll have to play around with at the bottom of this notebook. So these are some of the phenotypic parameters that are collected in that data. And this is a notebook that you can basically pilfer for your own use cases. So feel free to take this code to create things like univariate distributions, and bivariate distributions and box plots. So what we're going to do now is we're going to take a pause and everyone is going to try to generate their own plots by changing some of the parameters that are being plotted. So I'm going to go up here to my list, and let's say that I wanted to see, oops. Let's say that I wanted to see LDL instead of HDL. So I'm going to pause for a couple of minutes while people try it out. Feel free to ask any questions. We have a question in the chat. By default, the notebooks are not shared between the owners of the workspace. The content of the notebooks is shared between anyone who has access to the workspace. What isn't necessarily shared is the ability to run computations and edit the notebooks at the same time.
Okay, I did the question. It's because Huri and I, we were trying to play with the platform, and I did a notebook, and she doesn't have access, and I don't know what is happening.
So you have your own workspace clone, and you added your colleague to the workspace?
Yeah, we both are owners.
You're both owners of the workspace, and
yeah,
you can see the notebook, but your colleague can't?
Exactly.
Really?
Is that okay, Huria? She's here.
I get errors like can't load the bucket. It's another workspace that we created. It's not just a clone of this one. Yeah, we can't figure out why.
Do you feel comfortable sharing your screen?
Yeah, would you want to take a look?
Yeah, because we could kind of see what's happening that way.
Yeah, I will just need to find it now, and I'll share my screen if that's appropriate.
Yeah, absolutely. Just let us know when you're ready. Yeah, in the meantime, if anybody else wants to share what they tried with the various plots. So did anyone try anything other than the defaults that we had set?
Maybe need a little more time. Anton, how long do you think we should work on this, playing around with the notebook?
Just a minute or two.
Okay.
I'm ready now if I can share my screen.
Yes, absolutely.
So this is our, can you see?
Yep.
Yes.
So this is a workspace that we created, and there's data in it. The data loads. And you see, I keep getting these, I don't know if it's because of our billing situation, but when I go to notebooks, then I get these error loading notebooks, and the error looks like this. Something to do with the cloud storage bucket.
Interesting.
Yes, that's definitely a malfunction because the entire notebook tab isn't actually loading. So even if it were that you were looking at an empty notebook tab, you would see some options, like you would see the button to create a notebook.
Exactly. Yeah, and I am an owner as well, and it shows for Joycey. She created them. Everything shows for her, but even if she sends me the link to the notebook, I get the same errors.
Do you mind? I think I heard somebody taking a screenshot. Maybe
I
that was
did. I took a screenshot of your error message. I hope that's okay.
Yeah. Thank you.
Yeah. I was going to say, I think we're going to have to raise a ticket with the support team. Do you mind sharing your workspace that's having this issue with me so I can share it with the support team?
Yes, sure. Can you just copy your email address in the chat?
Yes, I can do that.
And you want what kind of access?
I think you can just do reader access for now and can
Okay.
share and
Yeah.
reader and can share. And then if I have any more questions, I'll let you know. And then if you just want to put your email in the chat as well, I'll CC you into the ticket with the support team.
Thank you.
Sure.
Thank you so much.
Okay, thank you.
Okay, we can get back to our demos then. So before we move on to the second notebook, does anybody want to share anything they played around with these plots? Going once, going twice.
I ran through those plots, no issues, but I have not modified any.
Okay, excellent. So long as you had no issue. Yeah, all of these are very well documented online. So even if you have trouble with, so like I noticed that sometimes it's a little bit difficult to use different kind data points because it expects very specific types of data, but you can usually troubleshoot that very well.
I have one question though related to the data. So so there are tables which are specific to my notebook or workspace. So in the bottom, in the other data, you have the workspace data and the files. So what's the difference between workspace data and the files in the data tab?
Great question. So first of all, between workspace data and files, between these two?
Yes.
So files, this tab just gives you access to your workspace storage, the workspace bucket. So you can upload whatever type of a file you would want. Here you can have images or spreadsheets, IPyNB files. Workspace data is for more specific types of files that need to be used as inputs for workflows. So an example is reference files or interval lists. Basically, when they're files that have to have other types of specific values associated with them for workflows to know how to handle those files, you would use workspace data. Does that answer your question?
So yes, but so we can't use the files in the files folder for our workflow execution?
You can use files in that are just added directly to the bucket like this for workflow execution, but some workflows aren't. Some workflows are optimized so that it's better to use them like this because they'll have other parameters that those workflows expect to associate with those files.
Okay.
So,
also related to, sorry, go ahead.
I was just going to say, yeah, so just to add to what Anton is saying, you can put files in your Google Bucket and add them as rows to this workspace data table, and then you can use them as you know, a parameter in multiple workflows. So if you ever have to change that file, that underlying file, you just have to change where this pointer goes to, and then you don't have to change all of your workflows. That's kind of why it's there, so that you have a way to like point to like a variable, like this is A, and you can configure all of your workflows to point to A, but then you can just change the file if you ever need to change a file. Does that make sense?
Yes.
Okay.
Okay, I have a question in the same ways. If I have my home table in my computer, how can I use it in how can I use it or not to clone existing data? How can I use my own data?
So that's actually what the following demonstration is going to be about. We're going to upload TSV spreadsheet, and we're going to read it into our notebook. Will that kind of be helpful in answering your question?
To use my own data, I have some data I collected in the field, and I went to download it in my workspace and create a notebook to write my script.
Yeah, absolutely. So that's more or less what we're going to do now. So I'm going to go to option 2, data in a workspace bucket. So this notebook will show you how to access data that's in your workspace bucket. I guess because of the questions everyone's asking, I'll kind of switch around the order of things, and first I'll upload something to my workspace bucket. So I'll just upload this TSV spreadsheet that I had copied from another workspace. And the exercise that I'll have everyone do in a moment is to just go to another public workspace, such as the original public workspace that we cloned this one from, and go to the data tab and download a table, and then upload that table to their files tab. Once you've done that, we'll have to run through this notebook. So hopefully everyone is following along at this stage, because it's important for me to point out that after we run this very first pip install session info cell, we have to restart the kernel. I'm going to eat my words if this cell works right now without us having restarted the kernel, but it shouldn't. Yeah, so for whatever reason, for this particular package, I just want everybody to be aware of that, since this is a hands-on exercise. You have to restart the kernel, which you can do either by clicking on the kernel menu and clicking restart. There's also a button right here for that, restart the kernel. I'm going to restart, because all variables will be lost, that's fine. You can see here that the kernel is working. So while this dot is full, that means the kernel is busy. Once the dot is empty, it says the kernel is idle, so it's ready to go. Now this should work. There we go. Right, because the session info needed to be updated. So once we have that, now we need to set our environment variables again. And in a lot of ways, this notebook is exactly identical. The difference is that now, instead of grabbing our sample table from the data tables, we're going to grab it from this bucket. We're going to use this Python magic. We're going to use the exclamation point to run a gsutil command right in the notebook cell. And we're going to copy.
Hey, Anton.
Yes.
Hey, Anton.
Yes.
I think you're quite fast.
I'm sorry, I can slow down.
Yeah, kindly.
Can I ask where are you?
I went back to the same workspace where I copied mine from to look for the Terra notebook quick start that I had not copied. The original workspace. Yeah, that's where I am.
Okay. I'm sorry, I should have been clearer. We will do that exercise in a moment. So let's start by just running through the notebook as it is. And once we finish running through the notebook the way that it currently is, then I'll have everybody go find some other file to upload to their table or to their files tab. So
it's okay.
I guess one more time really quickly, if everyone can open this option 2 notebook and run through the 3 setup cells, remembering that after you run the first setup cell, this pip install session info, you have to restart your kernel. in order to be able to import the session info package. So by show of hands, can I ask how many people are following along at this stage? Or does anyone need to catch up still? I see a few hands. If anyone is behind, feel free to just chime in and ask. Why did that pip install info not have an exclamation in front? I'm used to prepending exclamation to a cell to indicate a console command. That's a great question. I'm not certain. I don't know, Tiffany, maybe you know?
Let's see. Are the other pip installs in this workspace, do they have, or in this notebook, do they have exclamation points?
I don't know if there are other pip installs. I don't think
No,
there are
there's
other pip
not.
installs.
I don't know.
I'm not certain, but it works. So okay, I'm going to continue along.
My guess is because maybe it's a Python thing, and the others, if you're trying to do like exclamation point gsutil or ls, that's more of a bash terminal thing, but I'm not sure.
And I just want to point out that after we ran our gsutil copy command, now we can see the demo pheno data TSV in our workspace bucket. So that's under the files tab. So after we ran this command, then this file showed up in our workspace bucket. However, our workspace bucket is still separate from our virtual machine. The virtual machine has its own storage. And in order to pull files into that, you still need to do this. So next you will load the file from the workspace's storage bucket to the cloud environment virtual machine running this notebook. So first we'll set some environment variables. We'll print them out to make sure that it worked. And then we will go ahead and copy it. And then we can run regular ls command line command just to see that everything is in here as we expected. And indeed, there is our demo pheno data TSV. And just to check that it's exactly what we were expecting, we're going to print out the top 6 rows of it. And I'm going to pause to let everyone catch up and make sure that this is working for everyone. So I'll give everyone a minute or so to please pipe up if they're having any problems. At which moment do we have to refresh the kernel? After you run the first pip install cell. So in this section 2, when you run pip install session info, as soon as this cell is done, then you restart your kernel. Otherwise, this cell will error out. Oops. And the rest, so the rest of this notebook functions exactly the same. And that kind of demonstrates how to import data into the workspace bucket. So now we're going to pause and do the exercise that I mentioned earlier. So everyone should go either to the original workspace or to really any workspace that they like. And what you can do is you can either click download all rows, and it'll download a TSV file containing whatever is in that table. Now I have this cohort TSV. And then go back to your clone, to the data tab of your clone, and upload it to your own bucket. So I'm going to give everyone a moment to do that.
Anton, question. When we are copying that file is copied to the running instance, or it's running copying somewhere in the bucket, because we are not giving any path. We are copying from a remote location to current location. So current location, I'm assuming, is the instance where this notebook is running.
Can you clarify, do you mean this copying in section 3.1 or this copying in section 2.4?
The next one.
This one right here?
Yeah.
So in this case, you're copying a file from your workspace bucket to the virtual machine that's running this notebook.
Okay, got it. Okay.
And once you do that, don't forget to run this cell over here. So you might have noticed that I errored out when I first tried to skip over it to come over here, but we haven't defined some of the necessary functions for that. You'll notice that we have enabled this hide function for some of the longer cells. So you can click there to expand it. You don't need to expand it in order to run it. You can just run it. And then once you do that, you can generate the exact same plots as before.
So as you uploaded the new file in the files bucket, you still have to copy those to the instance before you can run any command on the notebook.
In this demonstration, yes. There are ways that you could just point at that bucket location, right? So you could just have a command that looks for that specific bucket location, but it can be more convenient for interactive analysis to just have the item in your virtual machine.
Got it. Thank you.
So I'll take another minute or two to let people complete the exercise. Once you are finished, could you please raise your hand in the participants list? And once everyone or most people have, so leave your hand up so that I can tell that most people are finished and we can move on to the third notebook.
Anton, if you don't mind, can I ask a question related to the tables that is in the workspace? How
Yes.
those tables are different than files? Are these are different data type in the Google Cloud?
How are, so comparing these tables with
Files,
any types
yes.
of files that go here?
Yes.
So these are all basically TSV format spreadsheets, whereas you can store any type of file in the Files tab. So you can upload notebooks. In fact, the one folder that it always comes with is a notebooks folder that contains all of your IPyNB files. These tables, on the other hand, are a way to organize metadata that includes both phenotypic data, but also it can contain links to genotypic data. And this actually is not, this is not a table that has a good example of that.
Okay. Yeah, I got it. I just uploaded the phenotypic data just to try.
Okay. So yeah, you can organize phenotypic data, and you can also organize genotypic data, which is so you'll see links to those files. So you can organize, all of your bucket locations into one table. So that's the purpose of the tables. Does that answer your question?
Yeah. So it should be TSV file format if I'm importing as a table.
Yes.
Okay. Thanks.
I see only 5 people. 4 people have raised their hand. 5. If you're not following along with the exercise, that's totally fine. Just go ahead and raise your hand that you're ready to move on.
Anton, just a question.
Yes.
If I had data in CSV format, is it possible to upload it in this workspace or in Terra?
In CSV format. Tiffany, do you remember if CSV format just works for upload right now?
CSV, I think it needs to be TSV. Yeah, so tab separated versus comma separated, but maybe CSV works. If you try to click the plus button for the tables and you drag it over, does it have any issues?
Yeah, try. So it requests a TSV file. You can try with a CSV file, but you might need to convert it to a TSV file.
Yeah.
Okay. Thank you.
Sure. All right, so if everyone is okay, see the participant list again, it's gone. All right, I'm just going to assume that everyone's ready. And we're going now to go into the third and final notebook for today's demo. And that's option 3, data in the Terra data library. So this is a really cool demonstration because we are actually going to go to the Terra data library and construct a custom cohort of our own. Now my Terra is being slow. There it goes. I don't want preview mode. I think there's just a lot of us on here at once. Something funky is going on. There we go. Because this widget disappeared on me. Okay, now we're back. Hooray. We can kind of quickly run through the setup process. We don't have to think too hard about it. This set of packages is going to take a while to install. So everyone go ahead and just hit run on basically all of these packages. So what you can do actually is go all the way down to section 3 and click run all above. So I'm going to run this entire section of setup cells all at once. And that's going to take a little bit. So hopefully everyone's doing that. And you can follow along as I go to the data tab. I'm sorry, to the data library to create my own custom cohort from public data. So if everyone can be following along with this particular part of the demonstration, because you're going to do it for yourselves as one of your final exercises. So again, we'll go to the main menu. You can click on the main menu from anywhere. I'm just leaving this tab open for convenience. And click on library and go to data. And I'm going to click on browse data under 1000 genomes low coverage. Just to recap, everyone should be running their setup packages or their setup cells in the option 3 data in the Terra library notebook. And while those packages are installing, everyone should go to the data library, which is under the library, and then click browse data under the 1000 genomes low coverage, which is the second option on the top row.
Good question, Anton.
Yes.
So I have the Teradata library option 3 notebook open, and then cells, the environment setup cells, all of the cells in one. You want us to run all of those and then go over to part 1.
And then go over to part 1. I'm sorry, what do you mean?
Or sorry, finish part 1 and then go over to the data library to the low coverage.
Yes, so you don't have to
Okay.
watch. You don't have to watch as these install. It just takes a little while. So you can just go ahead and run all of those cells either by clicking run all or by hitting shift return on every individual cell down to section 3 basically.
Down to section 3. Okay, thanks.
So once you are here, and I'm going to wait just a moment to make sure everyone catches up, because this is the part that everyone's going to be doing. So I am now looking at what's called a data explorer, and this is a very nice part of the Terra user interface that we've integrated for certain public data sets, where it gives you a very nice clickable way to construct a custom cohort. So this cohort comes with 3,500 participants, and you'll see as we add filters, this number will go down. So for example, if I were only interested in female participants, then that would only be 1760 people. If I select both again, that's all 3,500 people. And at any point, I can save this custom cohort and I can export it to my workspace. And you have a lot of flexibility in what you can choose. So for this demonstration, I scroll down to the bottom of this population parameter and I select the bottom 3 categories just so we have a nice small cohort to analyze. So you can see we now have 317 participants in the cohort that we've selected, because we've selected people of Japanese, Finnish, and Mexican ancestry. I'm going to save this cohort. I'm going to call it cohort demo.
And should we do the same or wait and establish our own cohorts?
Please feel free to follow along.
Okay.
If you don't, then feel free to create your own cohort as part of the exercise that we'll do once we finish this. But it'll be easier if you do it twice yourself. I'm assuming everyone is following along because they won't be able to do the rest of the notebook unless they create a cohort. Oh, actually, I'm sorry, that's not true because there is a cohort in this in their clone already. So they could do it without creating their own cohort, but I recommend doing it anyway. And so once you have created your cohort, you can either create a new workspace from scratch, or you can start with an existing workspace, which is what we're going to do. So I'm going to start by going to this one. And what's the difference between these two? Why do these look identical? I think it's this one. If I import that to here. Yes, it worked. So yes, I'm sorry, there's already a tutorial cohort in there. So you will be able to run through the rest of the notebook if you didn't create your own cohort, but I've also added a cohort demo. So you can see under the cohort tables in my tables section of my data tab is both the tutorial cohort that we started with and the one that I just created.
Anton, question. In the data, the cohort, it imported in the existing cohort table rather than new one. What made that determination that I want in the existing one, not the new one?
Because it matches the entity type. So when we created that cohort, when we created this cohort, it has a certain entity type associated with it. And that entity type is the cohort ID entity type. And that tells it to organize it with other tables that have that entity type. So if you really wanted it to have a different table, what you could do is, let's see, can I do this quickly? I don't think it would be quick enough for this demonstration. But basically, if I downloaded this table as a TSV and I modified just the top left cell, and then I re-uploaded that TSV through this button, then there would be a new section with whatever is the new entity type, assuming you formatted the entity type correctly. And we have a lot of documentation on formatting entity types. Does that answer your question?
Yeah, I'll try that.
Okay, so moving on to this notebook. So I'm now in section 3. Hopefully everyone's ready to follow along. We're going to start by doing a little bit more setup. So these are the cells that allow the notebook to look at the cohort query. So we're going to create a variable called cohort query. And what we're going to store in it is this query that we just created when we created the cohort. And so for that, we need to specify the cohort entity. And when we print that out, we should be able to see the details of our query exactly as we selected it. So you can see we're printing out 2 of them because I have 2 cohorts now, right? I have my cohort demo and my tutorial cohort, and you can see both of those are printed out here. So I have a cohort demo query here, and it specifies exactly what it was that I selected, right? So there's my population description that I selected. And it also prints out the tutorial cohort, which was already a part of the workspace. So the cohorts, because they're metadata, those do carry over when you clone a workspace, because that's just part of the data tables.
Good question, Anton.
Yes.
Sorry if I missed this, but when I run the cell cohort query, cohort entity to attributes query, I have an error in cohort entity. Is that, it doesn't appear to be doing anything, but that's, I get a little error message when I run that one. It says subscript out of bounds.
Interesting. Do you have a 2 or a 1 here?
I have a 2.
And did you add, so did you end up adding a new cohort right now?
No.
Okay, so what this refers to is the number of the entry on the sheet. So if you have a 2 there, it's expecting at least 2 entries on the sheet. So if you change that to a 1, it should work now. Does that work?
Let's see here. Yes, I don't get an issue.
Okay. And when you print it out, then, so when you hit the next cell, then you should see a printout of just the one cohort that you have.
That's right. Yep.
So I'm curious, if I just do that, will it only print out one cohort for me, even though I have 2 in the workspace? No, it still prints them both out. But yeah, that's what it means when it says subscript out of bounds. It basically says that the table that the cell is pointing at is smaller than the cell is suggesting.
Got it. If you just change that from cohort underscore entity to cohort underscore query, do you think then, not that cell, the bottom, the next cell, do you think then it would show just one since it's?
Oh yes, good point. Yep. So then it just shows.
Doesn't look as nice as before though.
Yeah, so that's interesting. So I can select which one of the 2 cohorts, just like that, right? If I want to do the first one as it's listed on my table, so this will be the first one, which is the new one I created, cohort demo. And I see these selections that I made. People of Japanese, Finnish, and Mexican ancestry. Whereas if I look at the second entry, then it will be the other query. Okay. So now that we've done that, we should be able to generate, plots from that. So I'm going to start by just making sure that I can actually print out the data in the query.
Another question, Anton.
Yes.
And so we're using BigQuery here because this low coverage data set is all stored in BigQuery. Is that why?
Yes, I believe so.
Okay.
So once we've retrieved our query, we can add data by joining it with another table. So the query you just ran returns the participant IDs. So these are the participant IDs for the query in the previous cell. To do an analysis, you'll want additional information from the data set. So in this section, we show you how to access additional data by adding information about gender to the participant ID. So what we're going to do is take our query and join to it information about gender from another query. So you can see our table now has 2 columns. And 200 participants. I think that's because we're working not from the I think we're working from the tutorial cohort rather than from the one that I just created. And we can generate this nice bar graph comparing male and female participants. Now, one thing I like to do in this demonstration that I think will work, unless I'm mistaken, is to show how I can change that for one of the other parameters that I used in creating my cohort. So I'm going to change gender to population here in the query that I'm joining to my table. And I'm going to change gender to population here and here. So this might not work because of how many times we changed our queries. So that number is not what I would expect it to be. Oh, there we go. Yeah, it did work.
Could you show again how you started changing that query? Sorry, I missed that.
So changing the query from gender to something else?
Yeah. Okay, that's right.
That's
yeah,
done
okay.
in this cell, the first cell in section 5. So where I write the new query under the code select. I select for population. And so actually this is the tutorial cohort, probably because of all the playing that we did while we were over here. Right, so cohort entity. Yes, but what if I want that cohort instead? Will that allow me to see what I want to see? Yes, now that's going to look at my new cohort. I can see that it now has the number of rows corresponding to the number of participants that I selected. And this should now be, so since I specifically selected for 3 populations, this graph should now have 3 bars: Finnish, Japanese, Mexican ancestry. So at this point, I'm going to pause for 5 minutes so that people can try this out on their own. Feel free to ask any questions. We'll just sit here. I see some raised hands. Please just go ahead and call your questions out or paste them in the chat.
Just a question, Anton. Hi.
Hi.
Yeah, I'm so interested in the BigQuery. Is it a library? Is it a free library, or is it an enterprise library, or is it part of the Google platform functionality?
Tiffany,
The
can you
BigQuery.
answer that question at all? I'm not super familiar with BigQuery.
Yeah, so it's a part of it's a Google Cloud Platform product. And I believe the reason we're using BigQuery is because they do make some data sets publicly accessible, free, they store them and you're allowed to access them for free. So that is a reason we use BigQuery sometimes.
Just a follow-up of the same. Can you be it just like the other libraries in different platforms other than Terra, on Terra platform? Can I be able to use it elsewhere, like in my local machine while playing around with Python?
Can you access BigQuery on your local machine while playing in Python?
Yeah.
Ooh, that's a good question. I don't know. I've only played with BigQuery in the context of using Terra.
That's okay.
But if you go to their website to like just BigQuery on Google Cloud Platform, I'm sure there's probably ways in which you could pull the data to your local machine, or at least stream some of the files from BigQuery. Yeah. Does that help?
Yeah, thank you. It helps. Yeah.
Okay, good.
Aiton asks if there's a way to find running notebooks if I closed a tab. Yes, absolutely. It's very simple. You go under your name. So anywhere in Terra, just click on the main menu, go under your name to Cloud Environments. So here's the one that I'm working on right now, and that should, oh, well, it goes to the workspace where you had the notebook. So you'll have to just go to the notebooks tab and click on the same notebook again. But at least it will take you to the workspace where that notebook exists. Does that help, Peyton? Great.
Yeah, Anton, I have a quick question.
Yep.
Yeah, my internet has been very bad, so I've been going on and off, but probably you've answered this before. When installing the R packages on the cloud, if we are all working on the same workspace, would each person have to do the installation, or the packages will be stored in the workspace such that anyone would not, like the other person will not have to install it before it's used?
Great question. No, you do have to install the packages whenever you create a new cloud environment. So the workspace is separate from the cloud environment that's doing the notebook computations. And so whenever you create a new cloud environment, you will have to reinstall packages. There is a way to streamline that process that I'll talk about as soon as we're finished with this notebook. Basically, there's a way to make sure that you have a custom cloud environment that starts up with all the packages that you expect without having to go through installation steps.
Thank you.
Yeah, it's interesting because if you think of like the workspace, you know, people can collaborate, you know, in real time in the workspace, and with these notebooks, since everybody's has their own cloud environment that they're working on, when you're installing software, you know, everybody's got their own kind of like blank slate to start with. But once you install it, you can, you know, you can save your packages to the persistent disk. So that, and I think Anton's going to cover that, like whenever you are then, you know, trying to spin up that cloud environment again, you don't have to download everything all over again. So that's just kind of a distinction between how like you're working in the workspace versus when you're all working in the same workspace, but you all have different cloud environments. Kind of think we need a diagram for it or something.
We have a few.
Oh, good.
Okay, I think we're going to be ready to move on soon. I see there's still 2 raised hands in the participant list. Is it that you're done with the demo, or do you have questions? Can I assume everyone is ready to move on? Excellent. I see a thumbs up. Thank you. All right, great. So that kind of takes us through all of the notebooks that we wanted to demonstrate for you today. There is, for those of you who are curious about BigQuery, there's a 4th notebook that goes into a little bit more detail for using BigQuery. There's a Jupyter Notebooks 101 notebook for anyone who's a novice to using Jupyter Notebooks. It kind of gives you all of the tips and tricks about hotkeys and how to run notebooks efficiently. And then, so I'm not going to pause the cloud environment because I don't want to necessarily waste time if we want to go back to start it up. But I do want to take a moment now to explain some of the options that you have when you're creating a custom cloud environment. So when you click on the cloud environment widget, you will be able to see this set of options. If you click it when there is no cloud environment existing, then first it'll ask you whether or not you just want to create a default one or to customize. If you click customize, then you will be taken to this view. You'll be taken to this view automatically if there's already a default environment running there, because obviously if you want to change something, that it's going to be anything other than the default. So when you're in this view, you can see, first of all, a real-time cost estimate of how much this machine will cost to run. That's while it's running. And also how much the persistent disk storage costs. So you can see that I can update all of these in real time. So if I decide I want 4 CPUs, now my running cloud compute cost goes up. If I decide to increase my persistent disk, then the cost of storage goes up. And so this is how you can control what kind of cloud environment you can make. And I'll come back to this section in a moment. This is kind of the most interesting and important part of what we provide on Terra. But in terms of the elasticity of the compute power that's available to you, there are a lot of options. So you can select number of CPUs, you can select compute memory. We also have enabled GPUs. I'm not sure why GPUs aren't clickable in this. Is it possibly because of the fact that we're in a different branded Terra? That's surprising. This should be working right now. But normally, if you click this checkbox, then you'll have an option for selecting different types of GPUs if you're interested in using them for things like machine learning. You can also select different compute types. So you can select a standard GCP virtual machine, or you can select Spark clusters or single nodes. And this feature is a very nice cost-saving measure. So all of these notebooks come with auto pause automatically enabled. So after 30, so in this default setting, after 30 minutes of inactivity, the cloud environment will automatically pause. So that's just to keep people from accidentally running way over by having, a bunch of tabs open with a bunch of notebooks and forgetting that they have those. So you can turn off auto pause if you're running some sort of computation that you really wanted to get to the end and you think it'll take longer than whatever is the auto pause set. But normally we don't recommend turning off auto pause. With that all being said, I just want to go back to the application configuration option. So the way that Terra cloud environments work is through a system called Docker. And Dockers are basically packages of software, including operating systems, that can be mounted onto a fresh virtual machine and create consistent, reproducible computational environments. So we have Dockers for so we have, for example, our default Docker, which includes these versions of Python and R. We have Hail Docker. We have a Python Docker. We have legacy Dockers for environments that might have been for environments that are older. So if you've shared an analysis with someone that was created a long time ago, and for some reason it's not working on the default application configuration, you could try a legacy application configuration in case some of the package versions have changed since then. And so basically, all of these represent Dockers, separate Dockers, and a Docker is basically an executable script for booting up a computer. So when you click create, or update, so I could click update environment after selecting something else, like, for example, RStudio. I know there were questions about using RStudio, and we have a separate Docker for RStudio. So I could update this environment like that. And what would happen is that the environment would be recreated and booted up again based on the instructions of this Docker image. You can also select custom environment. So if you're familiar with using Dockers, you can create your own Docker file and upload it to something like Docker Hub, and then use your own custom environment. And so that would be a way to get around having to reinstall the same packages when you're collaborating with others. You could just create a Docker image that has all of the packages so that you can consistently share the same environment with everyone. So you can do that either with Dockers. You can also do something similar using a startup script. So a startup script is, it's similar, it has a similar effect to a Docker, but it's a little bit less far reaching. A startup script can just include some installation commands. So you can also create a startup script that lists a bunch of packages that you want to be included in your cloud environment. And when you create that cloud environment, it will run that startup script so that you don't have to have a bunch of cells in the beginning of your notebook for running those, for installing those packages. And we have tutorials on creating startup scripts in our documentation. So I'm just going to pause really quickly to ask if there are any questions about the cloud environment widget and all of the different options that you have when you're configuring your custom cloud environment.
Antoine, question.
Yes.
If I'm building a new Docker with my custom analysis, in that scenario, I'm assuming once I install, run that Docker in this environment, the workspace and the functionality will be as is, because that's a layer on top.
Yes. Well, not for the workspace, but for the cloud environment that is running that Docker. Yes, if I understood your question.
So yeah, once I have my new Docker that I run it in this, I should be able to use my workspace and my data files in the workspace as is on my new Docker instance.
Yes, exactly.
Got it. Thanks. One other question related to the data. The new cohort that we created, when I exported, I see that as a query rather than the CSV data file when I export it. So you have that cohort.tsv. If you open it, it's not a TSV data file, not here in the, yeah. So if you see, it's a data explorer URL. So once you export it, it gives you the query and the filters that you selected, not the data itself. So if I want to export the data, how can I get the data?
I'm not sure. I don't know, Tiffany, maybe you have some insight.
Can you repeat the question?
So here we created the cohort demo. If you export it, it exports the data URL rather than the data itself. So if I want to export the data, not the query, how can I export that?
Yeah, let's see. I think that the idea is that you're not moving the data, you're analyzing it within, you're analyzing what you need, but I don't think I'm answering your question. So let's see.
Yeah, I can write R and parse it and dump it. That's possible, but it should be, I should be able to export it directly from here rather than doing a workaround.
Yeah.
I'm not sure. We might have to get back to you.
All right, thanks.
Okay, I think we're going
Anton,
to. Yes.
one question regarding Terra. What is your what is your other competitor? Because I believe it's always good to know about other, is it parallel platforms? And what competitive edge do you have over them?
Who would you say are our competitors, Tiffany?
Yeah.
Yeah, so sorry, Daniel, I didn't mean to interrupt you. What were you going to say?
Yeah, okay. I hope you had my question, Tiffany.
Yes, I heard your question. Yes.
Yeah.
Competitors. So Seven Bridges Genomics is another cloud platform. We work actually very closely with them on a lot of NIH projects, and they have their own cloud platform. It is different in terms of how it's architected. And they also have a different workflow language that they use. They use CWL, and we use WDL. They use a common workflow language. We use a WDL workflow language. There's some differences in like the usability of the systems and features. They typically charge for you to use Seven Bridges on top of charging, you know, for the cloud vendor fees, you know, for usage and everything. So I would say like a competitive advantage is Terra is free. So people like to use Terra because it's free. Terra itself is free, not, you know, obviously the cloud services. Everybody that's in this space uses a cloud vendor and will charge for cloud services. So another example would be, I'm forgetting their name, DNA Nexus. They're another company that provides a platform similar to ours, but they also charge for it. So DNA Nexus and Seven Bridges Genomics are both for-profit companies, and so they need to make money. Whereas the Broad Institute is a nonprofit. We're developing Terra, so we don't have that same sort of motivation for making money as the other companies. They exist, they have to. So yeah, so those are some differences, I would say, and a few examples of competitors. I'm sure there are others, but those are kind of the ones that are top of my mind.
Thank you so much. Yeah.
Sure.
So since we have about 5 minutes left before we should rejoin the big room for wrap up, I want to make sure to demonstrate one final thing, which is opening a terminal view into the cloud environment. That's one of the really nice things about Terra, is that I can open a command line terminal, again, using this button right here. So right next to the cloud environment widget is a little button. If you hover over it, it says open terminal. So everyone should go ahead and do that. And when you do that, it's being kind of slow for me. Why are you being so slow? There it goes. And now we have a command line terminal that's looking at our cloud environment. I can list all of the locations in here. I can change into my workspace. Oh, but it won't like. So it doesn't like it when there's those empty spaces. So I'll have to put quotes. Why? Oh. I inserted all these. Shouldn't do that. Goodness. There we go. That can work for me now. There we go. So inside of this directory, there's a directory called by the name of my workspace, and that's actually the Workspace Bucket that has the list of notebooks inside it. So I can change into my note, my editable list of notebooks. And so this is also where we've been copying all of our files. And as a last quick demonstration, I just want to show people how easy it is to copy files into this location and how easy it is to grab commands for copying files. So for example, if I wanted to copy this file, so I'm looking at the Files tab inside of the Data tab of a workspace. Can be any workspace where you can look inside of the files. And at the bottom, there's a terminal download command, which is a gsutil cp command. And if I copy that to my clipboard, I can literally paste that exactly as is. And I have successfully copied that file into this location. So with that, I'm going to let everyone play around in their notebooks terminal command for a couple of minutes. And then we'll rejoin the main room. And please feel free to call out any questions about what you've seen. Maybe now is a good time for more specific technical questions about the hands-on exercises, whereas if you have kind of higher level questions about Terra's capabilities, you could save those for the main room, since probably everyone will benefit from them. Does anyone have any questions? Feel free to use the raise hand option to indicate that you're all done. And then I'll leave everyone with one last kind of take-home assignment, take-home exercise. And then we'll rejoin the main room.
Antoine, question.
Yes.
So all the packages or the images are released on the Docker Hub for the Terra at this time?
Yes. Right?
I believe they are at the Google Container Repository, which is just like Docker Hub.
Oh, that's right. We switched all of ours to Google Container Repository.
Yeah, I mean, some of them might be on Docker Hub, but I know that we also use a Google Container Repository, and I think that we have been actively trying to continue to use them. We have an article also on our site that links to previous versions of the Docker containers that are living within the Google Container Repository still. So if you ever see updates to the images, you can always go back and check out the old ones too if you need to use them.
By the way, do you know you have the container for lab key? Because we are planning to use it, and I wonder if Terra did something similar.
What was the tool?
The lab key?
Lab key?
Yes.
Okay, I'm not sure if we have that, but the way you would add that is we have instructions where you take basically this Terra base image that you can build from, and then you can try to use lab key. You can try to install that on this Docker container, and then you can try to bring that to a cloud environment to have it set up. Yeah, what I would recommend doing is looking on Docker Hub and Google Container Repository and seeing if somebody else has already created a Docker container for your tool. And then I would try to merge that Docker container with the Terra base image and basically combine the two to try to get that to work. If you have any issues, our support team can help you out with making that work.
Okay, thanks.
Okay, sure.
Thanks, Tiffany. And we have like 20 seconds left, so I'll just say that the last exercise was to go to the showcase section and find a workspace with a notebook that you find interesting, and then to send that notebook to your workspace. So copy this notebook to another workspace like